No, not yet. Try logging out and login again. Yeah, Krishna. Hello.
Sir, can you little bit refresh on week 7, sir? To be honest, yeah, I have not started week 7.
Okay. Okay. We will
Just a
start.
small introduction, then you can
Yeah,
start.
yeah, sure.
Thank you, sir. Thank you, sir.
Okay. So today we will be discussing week 7, where our new topic in mathematics starts, which is calculus. So week 7, 8, 9 are related to calculus part.
Sir, I have a doubt in GA 6.
Graded assignments.
Yes, sir.
What was the doubt?
Sir, I have doubt in graph related
Question
question.
number?
Wait.
Okay. I will wait. Okay. So basically, in week 7, what we have is some topics from weeks 1 to 6 has been discussed. And later,
Sir, question number 4.
okay. Question number 4.
Yes, sir.
I also have doubt in the same thing.
Sir, what is the difference between a strictly decreasing or simple decreasing?
See, strictly decreasing means less than. Okay, I will just explain. Why isn't it? Just give me a second. Okay, consider the function f of x is equals to log 12 plus 4x minus x squared to the base 2. Right?
Yes, sir.
Okay. See, basically, strictly decreasing means if I take 2 points x1 and x2, where x1 is less than x2, if my f of x1 is greater than f of x2, okay, it should be strictly greater than.
Yes, sir.
Then I say this function is a strictly decreasing function for any x1 and x2.
Okay.
X1 and x2 belong to my domain. Okay, there is a function domain to range.
Yes.
If I define a function like this, if I take 2 points in the domain where one point is less than another point, where one value is less than other value, my f of x1 is greater than f of x2, then it is strictly decreasing. If it is
When
like
sir,
less than or
when
equal,
x increasing, fx monotonic nature is decreasing.
yeah, if x is decreasing, if my f of x is increasing, then it is a decreasing function.
Sir, again.
Okay. So see, I have some function. I take two values, x1 and x2. Okay. If your f of x1, which is greater than if your f of x2, this is f of x1, and this is f of x2. Clearly, f of x2 is less than f of x1, and x1 is less than x2, right? If I take any 2 points like this, if my graph is like this, okay.
Okay.
If I take any 2 points, my x coordinate of compare the x coordinates and y coordinates of those 2 points. So take this point and this point. X coordinate of this point is lesser than x coordinate of this point, but y coordinate of this point is greater than y coordinate of this point,
Yes.
right? So if it is opposite, then we say it is strictly decreasing function.
Okay.
If it is like x1 is less than or equal to x2 and f of x1 is greater than or equal to f of x2, like these functions, so it is decreasing and it is constant for some time and it is decreasing again. This I will say this is a decreasing function, but it is not strictly decreasing function.
Okay.
So for two values, sometimes your f of x1 may be equal to f of x2. Okay, for these two values, it may also be equal. Even if it is equal, we consider it as a decreasing function. But this is not valid for strictly decreasing case. Okay.
सर when जब x 2 to infinity रहेगा तो फंक्शन ये डिक्रीजिंग होगा कि नहीं इस क्वेश्चन में, मतलब
Okay.
क्वेश्चन नंबर 4 में.
Okay. This question, you see the log of. Okay, I will come to week 7.
fx is equal to log 2 base 2 12 plus 4x minus x square.
12 plus 4x minus x square.
Yes.
So this can be factorized, right?
Yes.
Log 2 12 plus 6x minus 2x minus x square. Right?
इस हाँ इसे तो पॉजिटिव होना चाहिए.
So this is, if I factorize it, I will get minus x, 6 minus x into something like x plus 2.
Mhm.
See?
Yes.
Now this should be greater than 0.
Yes.
Right? That is our domain.
Yes.
Now, when will 6 minus x times x plus 2 be greater than 0? No. So this can be written as x minus 6
Yes.
less than 0. So
Yes.
this should be less than 0. Right?
Yes, sir.
Now, this will be defined in this particular interval. This. Right?
Yes.
Right? Roots are minus 2 and 6. So this will be negative in between roots. So if x takes value between minus 2 and 6, this particular product will be less than 0. And this 6 minus x times x plus 2 will be greater than 0. Okay, our defined interval, our domain is x belongs to minus 2 to 6. So is something wrong here then? Okay. Have you plotted this function in Desmos?
Yes, sir.
किसका इंटरवल में आ रहे हैं this function?
2 to 6.
minus 2 to 6.
So this is right.
This is right, minus 2 to 6. Is it? So we can only talk about in this particular interval.
Yes.
Okay. So option 1 shouldn't be correct in my understanding.
1 होगा कि नहीं सर?
Minus 2.
2 to infinity.
1 नहीं होगा. 1 it would not be 1. I discussed this with Vicky sir yesterday and discourse
Okay.
because it is not defined for beyond minus 2. So from minus infinity it would not be a 1 function.
Yeah.
So there's a mistake in the answer.
Yeah. I
That was
discussed
my
in discourse.
answer. That was my also concern. Okay.
We shouldn't talk at all because this particular minus infinite to minus 2 is not in our domain itself. So yeah, we will change it. Okay. Don't worry.
Right.
We will consider it. We will ignore the question or we will give it as an add score.
Yeah, sir.
Okay.
Hi.
सर ये बोनस मार्क ना?
ठीक है, ले लेंगे.
Yeah, one is better.
Okay.
10 नंबर चल गया.
Excuse me.
Yeah.
Good morning.
Yeah, good morning.
Are we going to summarize week 7? I mean, what is the agenda for this session?
I am about to start to summarize week 7.
Okay.
I just wanted to take questions, but some of you were asking to summarize.
I have one doubt in logarithmic equation. Shall I ask it now or at the end? How
At
how
the
is it?
end is better. So because
Okay.
we shouldn't
Yeah, one
Sure.
more thing. The slides for week 7 are not uploaded. So So is there a reason, or will they be uploaded?
No, is it not in resource from instructors thing?
No, it's not there.
It should be.
Sir, one
let-
request, sir.
Let me check again.
Yeah, please check.
Sir, can I make a
Can you
request,
please
sir?
explain
Yeah.
what is that actually? There is a
Sir, week
there is a
7
question in
content.
activity.
One second.
Activity
One by
question.
one by one, please.
Yeah, I have checked. They're not there.
They are not there. I can
Mhm.
see week 7 slides. Okay, let me check again. Okay,
Yeah,
I will ask them to upload.
because that would be very easy to go through very quickly what are the contents on. Now it is impossible.
Definitely, you will get every week slides. Okay.
Exactly. And as of now, I have not gone through those. Through the videos, so that I wanted to know what are the contents.
Okay. So what all you can see in resource from instructor tab?
Just a moment. Week 7.
Sir, can we ask week 6 question also?
Maybe at the end. Just give me some 40 minutes. I will just quickly summarize what week 7 is.
Sir,
Okay.
please, sir, because
Yeah,
9:30
and
we
I
have
will
to.
Yeah.
We have to move to office work.
Oh yeah.
Okay,
Okay.
okay.
Okay, thank you, sir.
Actually,
Thank you.
we pushed this to 8 a.m. So let
Yes.
me utilize
Week
this
7,
first
yeah.
1 hour first.
Yes, sir. Please,
Yeah,
thank you, sir. Thank you.
Maybe I
Okay,
will-
they are available. I'm sorry. I was looking in supplementary contents, but they are available.
Yeah.
Yes.
So
Okay.
in the resource from instructors tab, you will get slides. for
Yes,
every-
yes, they are available. Thanks.
Okay. Let us.
Sir, sorry to interrupt you.
Hmm.
I have a science bio background, though I was always good at maths. I mean, I got 100 on 100,
Okay.
but I opted medicine. I mean, so, sir, I just wanted to know if there could be a book that could quickly prepare me cover the 12th, 11th and 12th CBSE, so that I could come to the same level, because I'm struggling. I have bought all the RD Sharmas, but they are too thick. I mean, and the time is
Yeah.
short.
Have you gone through NCRT textbooks?
Yes, sir. NCRT, and apart from that, I had also gone through the book Prescribe, Introductory Algebra.
Yeah.
I could not find it in the market, but there was another one, sir, by Pearson. The topic, the name of the book is same, but it is by different authors. That is also Introductory Algebra, Real World Perspective, sort of. I mean, it's by Pearson publication only, sir.
Okay.
The one by the person who's there on the suggested book, sir, his book is not available in the market. It's costing around 15,000-16,000, but still it's not available. It's out of stock.
Okay. Bookfee.net. Have you searched in bookfee.net?
Sir, just give me a second, sir. I went to the local store. I am from Jaipur, so we have a market dedicated to studies.
Okay.
So the name of the book finally was Introductory Algebra, 11th edition, and it is by Margaret L. Yale, Johnny Horsby, and Terry McGinnis. And I compared it with, I'm not getting the name of the person, but I have downloaded it on my iPad in PDF format. So I covered quadratic equation on that. So yes, I got the application perspective. I had deferred my term. So I had qualified when the syllabus just covered quadratic in week 4. So when it was like polynomial in my quiz 1, it was totally bouncer for me, because I'm a full-time working professional also, sir.
Okay. So,
but it's easy. I could understand, and I was sure that I'm going to fail maths 1. But I managed to pass with around 50%. So yeah, I'm positive that I can still, clear this term. Otherwise, I had altogether lost hope.
Okay.
So yeah.
I think NCRT book is quite sufficient, and you attend
Yeah,
this
yeah.
online session. That is enough, actually. You
manage. Actually, I had attended I have been attending some of sir's sessions, and it really helped me, because I had
this
covered
is
all
sufficient,
the
actually. Online session and with first PUC and second PUC, that NCRT book, that is sufficient.
Yeah. Actually, I was not able to manage the sessions till 4th week, presuming that, Anis, you know it and you just have to. I have a habit of writing a lot, like all the science students. So yeah. Thank you so much, sir. I mean, you're a lovely
Yeah, I would like to add
instructor.
something. I also had finished my 12th in 2007, so it's 15 years. So when sets were first taught, I had to go to NCERT, cover the whole thing, and then come back to the lectures. So that helped.
Yeah. Me too. I did the same
Sir,
thing.
we will start the session, sir, 9:30.
Yes, sir.
Please, sir.
Yeah,
Yes,
Thank
sir.
you.
Sir,
Yes, sir.
please.
we will talk about this.
So what I was saying was, so
Yes,
you
sir.
you will have to cover up for in order to complete this course, you will have to do your background work.
No,
Yeah,
that is what NCERT, if is sufficient, I'll
Sir,
stick
it's
with
a
it.
request. Could you please summarize week 7? Some
yeah.
of us have a very limited time to do more
Sure.
studies.
Okay, let me start the today's session. We will talk about this by the end of the session, maybe. Okay, so what is okay, let me start from very basic things. So what is a domain? If I define a function, let me say some d to r. So what is the domain of a function? Simple function.
Is the input values it will take?
Input value of x.
Set of all
Values
inputs
of.
that this function takes. So when I say this function takes, it means that if I input that particular value into this function is properly defined, well defined, and it will give me a proper output. So then only this function takes this value, and all such values are called inputs. And if I keep it in a set, and I will call it, that set is a domain. That particular set is called as a domain. And what is range?
Output value
All
corresponding
outputs.
to out.
Yeah.
For the given input.
Yeah, the set of all outputs. So these outputs comes from these inputs. When I input a value in the function, I will get an output. So when I input all the inputs, I will get all outputs, and the set of all outputs is called the range. Now, what is codomain?
All possible values.
All possible
Values of actual values we can take, right?
Actual values or all possible outputs, or simply we can say where we expect our output values. So simply the set where we expect our output value. So whether it can be real number, whether it can be in the interval 0 to 1, whether it can be in the interval minus infinity to some 2, like that. So where we expect our outputs is called codomain, and the set of all outputs is called range, and the set of all inputs is called domain. Okay. So this is about a function domain, range, and codomain. So let us quickly summarize few functions. So what is a linear function? So some types of functions. There are some types of functions.
Ax plus c.
So linear function is also called as straight line. So it will be of the form f of
Highest degree is 1, right?
Yeah, highest degree is 1. So when a function is of the form ax plus b, we call it as a linear function. Okay. And quadratic, what is how a quadratic function looks like?
Degree 2.
Ax square plus bx plus c.
Bx plus c, where a not equal to 0. Here also a not equal to 0. Okay. So similarly, how recently we learned how exponential functions look like.
A power x.
A to the power x.
an x ki power n, an x ki power n plus an minus 1 x ki power n minus 1 plus up to 1.
No. I was talking about
It is a polynomial.
Not polynomial.
Acha, exponential. Okay, a to power x. A to power x. Yeah, sorry.
A to the power x.
Any constant to power x.
A is greater than 0. Right? These conditions also
Equals to 1.
A is not equal to 1 also was there, right?
Yeah, A is not equal to 1.
Yeah.
And finally, logarithmic.
log a base b.
Log a base b is a constant. There is an x there.
Log 2 base A of x.
Log x
Log x
base
a.
A.
Okay. What are the conditions here now?
X greater than 0 and not equals to 1 or greater than 1.
A not
No,
equal.
A is greater than 0 and
Greater
not
than
equal to
0.
1.
Greater than 0.
Right. So even here x should be greater than 0. Okay. Okay. So now let us discuss what is a decreasing function and increasing function. So as I said earlier also, so if I have a function with me which is defined from R to R, when I take two values from the domain, from this domain, if x1 is less than or equal to x2, then I should get f of x1 should be less than or equal to f of x2. Then I say it is an increasing function for any x1, x2. I just take simply two values from the domain x1 and x2 and I compare which one is greater. So if x1 is less than or equal to x2, same way I will compute f of x1 and f of x2 and I will check the inequality between those two. So if f of x1 is less than or equal to f of x2, it is increasing function. This is increasing function. Same thing, if x1 is less than x2, then if I get f of x1 is greater than or equal to f of x2, then it is a decreasing function. Opposite of increasing function. That's strictly decreasing means just remove the inequality signs. So graphically, if you want to look in graphically, so this is a decreasing function. This is strictly decreasing function. So this is decreasing. So decreasing can be constant in some area, but when it comes to strictly decreasing, it should decrease in any interval. It should continuously decrease. So this is strictly decreasing.
And I have a question. Why do we take less than or equal to? Why the equal to?
See, sometimes here itself, for some time it is constant, right? So when I take this value and this value as my x1 and x2, my f of x1 will be equal to f of x2.
Okay, so but it's still a decreasing function.
This condition will be satisfied and this condition will be satisfied and it will be a decreasing function.
Sir, in
And
case
what
it
about
is
if it's
Same here
x1
in
less than or
increasing
equal to
function
x2?
Same here, same for increasing one. And someone is asking.
And you have also mentioned if x1 is less than or equal to. So what would be the circumstance where x1 and x2 would be equal and yet it would still be a decreasing function?
No, it's just the notation we give.
Okay.
So just to make it understand easily. So see, if it is less than or equal to, you no need to worry about equal to sign there. It's just for uniformity, for no confusions or nothing. If there is an equal to sign, then
if it is a constant function, then this condition will be true. But can we say it's in decreasing or increasing?
Constant function is both. It is both increasing and decreasing.
Okay. So if a function is constant, we can tell it's increasing or decreasing, but we cannot say strictly increasing, strictly decreasing.
And constant function is neither strictly increasing nor strictly decreasing.
Okay. Thank you.
When I introduce strictly, constant function will fail both the cases. When I remove strictly, constant function will satisfy both the cases. Okay. Yeah, same for increasing also. Same goes for increasing. So for strictly increasing, it should increase. Continuously, it should increase. But for increasing, it can be sometime constant. So something like this for some interval, and after that it can be constant for some interval, and again it will increase. So this is strictly increasing.
And a constant function always remains constant?
Yeah, see, constant function is something like f of x is equals to some k. So
Yeah.
graph of that will be something like this constant line, right? This will be
Within a certain domain, even a function could be increasing or decreasing, and also even constant.
yeah. See, that will depend on how we restrict the domain, how we restrict the interval we look into. So this is on a whole, but same works for smaller intervals also.
In
Just
that blue color one, so if we restrict the domain, it is constant.
this
For-
thing.
Yeah, this thing is constant.
Yeah,
And
yeah. If
the
I
same
restrict,
graph, yeah, okay. After this green color, it is strictly decreasing if we restrict the domain.
right.
Okay.
Correct. Okay, so this is about strictly increasing, strictly decreasing, and now let us
Sir.
talk about.
Sir, can you suggest which book we should follow?
For this calculus part,
Yes.
so we have given, right? Didn't we?
No, sir.
Okay. Let me just check. Okay. So we have introductory to only one book is studied. Not sure. Is it? Okay. In the next section, maybe I will give you nice book for this.
Sir, for strictly
Okay, sir.
increasing, sir, so with a constant, so we can say it is strictly increasing. In that, I'm just confused.
No. See, if it is constant, then it will fail the property of, see, for strictly decreasing and strictly increasing, if x1 is less than x2, f of x1 should be less than f of x2. So
Okay.
this is only less than. There is no equal to sign here.
Okay.
Okay. For this condition will be failed by constant function.
Okay.
So this is for strictly decreasing. Strictly decreasing, sorry, strictly increasing. Okay.
Because,
if it is
sir,
same inequality, it will be increasing. If it is opposite inequality signs, it will be decreasing. Okay. For constant function, this condition will be failed. So constant function is not strictly increasing, but constant function is increasing function.
Okay.
yeah, in your graph, you
Graph
wrote
is
like that, sir.
yes, that's what
why
I
we
got
got
missed. Yeah.
Where?
that orange color you wrote
Strictly increasing, no, in
increasing.
that orange color, you wrote it.
Yeah.
That's why I got.
Yeah, that's why
sorry,
even
sorry,
I
sorry.
was.
Okay. This is increasing.
Thank you, sir.
And this is strictly increasing.
Yeah, no, clear.
Okay. Yeah, sorry. Okay, we will move a little forward and see some properties of functions. So if I have two functions, defined from R to R and R to R. So my domain is R and my codomain is also R. Now I say f of f plus g, adding two functions. So addition of two functions can simply be written like this, f of x plus g of x. So these are all pretty elementary things. So the same goes for minus also. If it is minus, this will also be f of x minus g of x. So don't confuse with these signs. So if it is this denotes, if it is plus, here it will be plus. If it is minus, this will be minus. Okay. Now fg. So this is product. This is not composite function, this is product. So composite function will be denoted like this, f circle g of x. So this is composite function. So if there is a circle in between f and g, that is called composite function. If there is no circle, if it is simply fg, that is product. There sometimes we will give us f dot g, even that is also product. And this is simply, you can write it as f of x product g of x. For division, we have an extra condition. So this is f by g of x can be written like this, but given that g of x is not equal to 0. So denominator should not be equal to 0 for me. Okay. Any doubt here?
No, sir.
No?
Sir, in this function, R to R is compulsory in both the function in F or in G.
Yeah. See, the domain where we define should be same, right? If you want to, if you are doing some algebraic operations in between two functions, this particular x should be both in f and g. So my domain should be same. So this particular x I'm inputting in g and also inputting in f, right?
Okay.
So if I am inputting that particular value x inside f and g, that particular x where it comes, so that particular domain of functions should be same.
Okay, sir.
Okay.
Okay, sir.
Yeah. Okay. Let me will move a little forward and see how a tangent to a curve look like. So how to draw a tangent. So basically a curve is set of all points that satisfies this function. If I have a function r to r, so defined as give me some function.
Sir, listen.
Yeah.
Sir, in the previous slide, sir, f of g, sir, the range of the g is domain for f.
No, not like that. Okay, you may be confused. Okay, this is domain of f. This is some codomain of f. I will just see one. So this is domain of g, and this is codomain of g. Okay. So this particular x, okay, I will say d1 and d2.
Yes, sir.
But you see, this particular x comes from d1 intersection d2.
D2.
Okay. This particular x, what I take should go into my function g as well as it should go into my function f. Right? So better not confuse with d1, c1 and everything. Just look in R itself. We don't worry about different domains. Okay. We will just worry about if a function is like this, some function is defined in the interval minus infinity to infinite, and there is another function defined in the interval minus infinity to infinite, and we will talk about properties. So
Sir,
when domain is yeah.
Yes, sir. X is the value that both g and f can take.
Yeah, g and f can take.
Yes,
Then only this f of x is defined and this g of x will be defined.
Defined.
Right? Like that. It is true for all cases. Okay. Okay. Now if I have a function f from R to R, so if I wanted to graph this function, graph of f is nothing but all points x comma y where x comes from, okay, domain and codomain, range, So this is domain and this is range, where x comes from domain and y comes from range. So plotting all these points x comma y on xy plane, I will get the graph of this function f. So if I take a simple example, when f of x is equals to 2x. Okay. If I wanted to plot this function f of x is equals to 2x on xy plane, what I will do is I will take the xy plane and I will take the set of all points that satisfy this function. So the set of all points will be like when x is 0, my f of x will be 0. When x is 1, my f of x will be 2, like this. So 0 comma 0, 1 comma 2, likewise k comma 2k. So all points k of the form k comma 2k, where k runs from minus infinity to infinite, I should plot. So I will start plotting 0 comma 0, 1 comma 2. So this is 2 comma 4, this is 3 comma 6. Likewise, there will be 2.1 comma 4.1. Likewise, if I plot all these points, so it will be something like this, and this will be a straight line. So for every value of x, there will be f of x. So if I join all these points, if I include all these points, this will be a straight line. Y is equals to 2x. So this is the graph of this function, f of x is equals to 2x. Similarly, when I take a quadratic function, x square plus 4x plus 4. So if I take this, so if I want to plot this, when x is 0, my f of x is 4. So 0 comma 4 is a point. So I will plot 0 comma 4. Similarly, when x is 1, this is x plus 2 and this is minus 2. Okay. So when x is minus 2, this will give me 0. So minus 2 comma 0 is also point. Likewise, if I take all the points that satisfy this particular function f of x, I will get like this. If I include every point, this will give me a parabola like this. So this is the graph of any given function. So graph, and let us talk about tangent lines now. So what is a tangent line to any curve? Anyone?
Line and curve are touches.
One by
A
one.
line
Touches at a one point.
exactly at one point
Right.
of a curve.
Correct. So
Now
if I
here
have
in
it
this video, the definition they define as in the direction, based on the direction.
based on the direction,
Based on the direction of the curve.
Based on the direction in which the particle is traveling at that particular point.
Yes. Instantaneous direction in which the
yeah.
curve
Right.
moves at the
Right.
point P. For me, it's not clear actually.
Okay. Simply it is like a particle is starting from here and it is moving on this curve. Okay. So it starts moving like this. At this particular point, it looks like this particle travels in this direction. At this particular point, just see intuitively. When the particle comes here, if it is falling from here to here, at this particular point, this particular ball tend to take this direction. Not exactly it will take this direction, but at that particular moment, what sir is mentioning is at that particular moment, the particle's direction will be like this. So if I throw a ball upwards, at every point the direction of the ball changes, right?
Yes.
Yes, sir.
So at this particular point, the direction of this ball looks like this, but at the next point, at the next moment, the ball follows this path and it will move to here. But after moving here, the direction of this ball will be in this direction. And after some time, after coming here, the direction of ball will be in this direction.
Yes.
But later, due to the gravity, it will fall again down. It will take this path. And after some time at here, the direction of this ball looks in this direction, but it will take this path like this. At that particular moment, the direction of the ball is what the tangent line. Okay.
Okay.
So at this particular point, the direction of the ball will be in this direction. Okay. You can treat it like this. If I suddenly remove the gravity at this point, the ball will follow this path, particular path. Okay.
If we don't understand this concept and we remember tangent as a
Fine.
no issue. Okay.
Fine, no issues. He just
Sir,
wants to explain what.
Sir, could you please explain? He has also pointed out that the tangent can cut a curve at 2 points, which is opposed to the notion that we know that the tangent cuts at a graph at only 1 point. So he has taken an example of a string-like graph curve.
Yes, Chair.
And there he has.
Yes, string. He draw a S shape, and yes.
Like this?
No, vertically, sir.
S only, PQRS.
S will not be a function, right?
Curve. He said a curve.
Okay.
A curve.
Okay.
And he draw a straight line, and he said it is also a tangent. It's not compulsion that tangent should touch at only 1 point, like that he mentioned.
Okay. So the thing is, at this particular point, if I compute the tangent, it will be something like this. But this particular line again touches at this point, right? It may touch at another point, intersect at another point. Even these lines are also called as tangents. Tangent is
but it violates that exactly 1 point, that condition.
Exactly 1 point, because we have simply defined what a tangent is, but the actual definition of tangent is in some particular interval, it should touch at exactly 1 point. Okay. So there is a polynomials, right? Like this. There can be.
So we take tangent with respect to the point, I guess.
With respect to that particular point.
Yes.
So that instantaneous definition is more accurate.
For this, that is why Sir introduced that instantaneous. Instantaneous will only deal about in that particular smaller interval.
So which is actually the definition?
Actual definition. For our conveniency, we just took simpler definition of tangent.
Okay.
He took the circle and he draw a tangent, and he told if you move inside, this tangent will cut at 2 points. If you move outside, it won't touch. Like this tangent will be explained that he said. But
he just went into some deep knowledge, but as of now, you don't worry about that much.
Yes, I think up to 12th that was not necessary. I mean, this was not necessary. We were dealing with simple functions. Yeah.
And he said straight line is also a curve.
Yeah, straight line is also a curve. So that is why we call it as a straight line. So why we introduce straight before a line?
It's like
that's why it's
it is as it is straight, so that is why we say that is a straight line, and it is also a curve. So straight lines are also curves, and if I wanted to find the equation of that curve, it will be simply ax plus b kind of thing.
Okay, thank you.
Okay, yeah. So yeah, tangents are basically, as of now, just remember, tangents are basically, it touches exactly at that particular point on the curve. Like this. So this is a tangent. And if I wanted to compute tangent at this particular point, I simply have to find a line that actually touches, it's not intersects. So this line is an intersecting line. So touches means it should not intersect, it should actually touch like this. Okay, this is intersecting, this line is touching. Okay, this particular line is called the tangent line, but this is not a tangent line. So this is just a simple line which intersects this curve at this particular point P. So they say point P. This particular line is a line that intersects this curve at point P. But this particular line is the tangent line to this curve at point P. So observe the difference between the line and the tangent line.
Sir, one more thing. Sir has also pointed out a word to a point nearby to the point P. Okay, the line does not cut the same curve at a nearby point near the point P.
Yeah,
So
yeah.
it can cut the curve at some other point.
Yeah, just now we said, right? We should just see the smaller interval around this point, around some point. Okay.
Sir, mute all.
Okay. Okay. Actually, tangents are defined like that. Tangent line is a line that touches at exactly one point around some interval of that point. A smaller interval. It can be very small. Okay, that is a tangent line. Okay, so these are some tangent lines. So there are tangent lines where the slope of the tangent lines will be 0. So those are the points. Those are called the turning points, which we have seen in week 5, I guess. So if there is a curve like this, if this point is a turning point, then the tangent at that particular point, the slope of the tangent at that particular point is 0. So if I draw a tangent here, the equation of this tangent will be simply y is equals to some constant k, which is parallel to x-axis. Once it is parallel to x-axis, the slope of that line is 0. So likewise, even this is also a turning point. And if I draw a tangent at this point, it will be like this. And the slope of this tangent will also be 0. So you can say that this statement will be evident. If the slope of the tangent line is 0 at
Maximum,
point P, then P is a turning point. Okay, if your slope of the tangent line is 0 at some particular point P, so if it is becoming 0, then I can say that particular point P is a turning point.
Excuse me, sir. Sir, for a linear function, the straight line is the tangent itself, right?
Yeah, you can consider like that, but we don't talk about tangent line because it is already a line.
Okay.
That particular line itself is a straight line. You don't worry about talking tangent to a straight line. So we will be dealing tangents only for higher degree, so more than one. So quadratic, polynomials, exponential functions, logarithmic functions, sine functions, cos functions. So these are the only functions we worry about tangents
Can
and
we
everything.
say there is no tangent exists for straight lines?
See, that is a debatable thing.
Okay.
Some say there won't, there will not be a tangent to the straight line. Some say the line itself is the tangent to every point. So I can't just conclude. So as of now, don't worry about it. Just leave it. Okay.
Okay.
Okay. So now let us dive into our important topic: sequence, limit of a sequence. Okay. So let us start by stating this. I have a sequence AN. What does this mean actually? So what does this flower bracket inside AN means? And I am saying that this is a sequence of real numbers.
A1, A2, A3, dot n.
Yeah, what?
Number of elements.
Yeah. So this particular thing states me that there is a sequence. You know sequence, right? One number followed by
Right.
yeah, one number followed by other, like that. So you will have a sequence of real numbers. This particular A1, A2, A3, and so on, AN and so on. This is a sequence where this AI's come from real numbers, and this particular inside term will tell me that the nth term of the sequence. So this particular AN denotes the nth term of this particular sequence. When I say this inside
Last term.
No, it's not last term.
Nth
It is
term.
the nth
Nth
term.
term.
Yeah, nth term.
Yes, sir.
So this is nth term. Okay. So this gives me. So in order to instead of writing all this, we simply write this. So this when I write it like this, 1 by n. So this tells me that this is a sequence of real numbers where my nth term is 1 by n. So in order to get the first term, just substitute n is equals to 1. I will get the first term. So when I substitute n is equals to 1, I will get the first term as 1. When I substitute n is equals to 2, I will get the second term, which is 1 by 2. Similarly, my nth term is, so when n is n, my nth term is 1 by n. Likewise. So this is a sequence. This is a sequence where my nth term is 1 by n. Likewise, I can say 1 by n square. This is a sequence where my nth term is 1 by n square. Likewise. So there are many sequences, infinitely many sequences of real numbers I can define. Okay. This is a sequence of real numbers. Now, once I have a sequence of real numbers, I wanted to check where this sequence goes. So whether it is going to one particular point, or whether it is going to infinite, whether it is going to minus infinite, or whether it is oscillating between 2 points. I just want to worry about that thing. And why we wanted to worry about that? So anyone? Why we are worrying about sequence limit for a sequence?
Is there
Because
any limit or it continues?
when we have to add or do some mathematical operation in such functions, so whether it is going towards infinity or towards 0 or towards point, whether it is converging or diverging.
Also to find the extreme behavior for graphs.
Yeah, correct. Good point.
Whether it's increasing, decreasing, whatever.
Increasing, decreasing, yeah. Okay,
Maybe
so
domain we are restricting the domain.
we are restricting
the domain.
So it is to
no,
find
this
the
is not
behavior.
function. We are not worrying about functions. We are just defining a sequence. I'm just looking at a sequence, and I'm worrying about where the sequence goes. Is it necessary to worry, or
No,
just like
is it continuous
It is,
or
yeah.
whether it will end somewhere like that, converge somewhere?
Yes.
Yeah.
It will to
So
find the
convergent
total
and
behavior of particular sequence, to know what is the nature of particular observations.
yeah, correct. Now, so we should worry about where this sequence goes, because there are lots of applications of this convergent. If it is a convergent sequence, then we can have a bound. So we will deal this bounds, upper bound, lower bound, and everything in maybe in Max 2. You will get a clear idea why we talk about bounds, why we need to worry about the maximum value, minimum value, how this optimization thing plays a key role, how this bounds play a key role in optimizing few things.
Sir, it helps understand time and space complexity in programming.
Right, correct. We will all see, but as of now, just believe me that looking at the limit, finding limits to any sequence is necessary. Okay, so how I conclude whether this particular sequence is going to one particular value or it is going to infinite or minus infinite. So if I say this particular value will tend to some value A, or this particular sequence will go to some value A, if I keep increasing n, if I increase n, if we increase n, then if my an is getting closer and closer to this value A, so closer and closer. Okay, that means, so if my first number, if my A1 is here, A2 is somewhere here, A3 is somewhere here, A4 is somewhere here, A5 is somewhere like this. If A6, A7, A8, and there is a bigger value A, so A20, A2000, A2 lakhs. So even how much bigger I take the value of n, this particular A2000 or A3000 or A3 lakhs. So A3 lakhs is the 3 lakh term of this sequence. So A30th lakh. So if I keep on increasing my n value, if my sequence is getting closer and closer to this value A, a single value A, so unique, and this particular A should be unique, a single value A, then I will conclude that this particular sequence has a limit and the value of that particular limit is equal to A, and I will simply write limit n tends to infinite an is equals to A. Okay, if this I can write only if this happens. If my sequence is getting closer and closer and closer to some value A, once I am convinced that yeah, my sequence is getting closer and closer to a unique value A, then only I can write this thing. My limit of that particular sequence an will be equal to A when n tends to infinity. Okay, this is a limit of a sequence. If this is happening, these type of sequences are called convergent sequence. So remember the name, convergent sequence. Convergent sequence means that particular sequence has a limit value. If this is not happening cases are like this. So if sequence an is tending to two different values A1 and A2, if my sequence an is going to infinite, if my sequence an is going to minus infinite. If these are happening, then I say this particular sequence an, I say Bn.
So how can it tend to both A1 and A2?
I will tell an example. Okay. So this particular Bn sequence is divergent sequence. Okay. Now let us take some examples where it is convergent, where it will take two values, where it will be infinite, and where it will be minus.
Sir.
Yeah.
Sir, in convergent sequences,
Hmm.
when n reaches to infinity and approaches to infinity, A is the maximum value the sequence can achieve.
A is the maximum or minimum. It can be maximum or minimum. It can go backside also.
Okay, it is either going to positive infinity or negative infinity.
It shouldn't go to positive infinite. It should go to some real value, real number.
Okay, sir.
Okay. So this is one case I have shown you. There can be like this also. Your A1 is here, your A2 is here, A3 is here, A4 is here, A5, A6, and it will all going to some particular value A backside, minimum value. It can achieve the minimum value also. Not always maximum.
Okay, sir.
Okay, but it should either go to some particular value, unique value A. Whether it is left side of your sequence values or whether it is right side of your sequence values.
But sir, for notation, we will always write n tends to infinity, not n tends to minus infinity.
Yeah, n tends to see here n is the subscript value.
Okay. It will always be positive, right?
It
A1,
will be
A2.
increasing
Yeah.
only. A1,
Right,
A2,
right.
A3, A4. This n is subscript value.
Yeah. Okay. Maybe the direction of the sequence is towards negative infinity or towards a negative some real number you said, but an is in a foreign notation, it's always increasing. A1, A2, A3, A4. Okay.
An is always where n will always keep increasing.
Okay.
Now let us see the examples. So first example is, if I have a sequence, 1 by n. So tell me whether this is convergent or divergent.
Convergent.
Convergent towards 0.
Converges to
0.
So this will, as I increase the value of n, this particular sequence will go closer and closer to 0. If you want to look on real line, so this is 0, this is 1. So my a1 will be 1, this is a1 here, and my a2 will be half. So observe, when n is equals to 2 is a2, that will be half. A3 will be 1 by 3, a4 will be 1 by 4, likewise 1 by 5, 1 by 1000, 1 by 1 lakh. But it will as I keep on increasing the value of n, this particular sequence will go very nearer and nearer to 0, closer and closer to 0. So no value that will go left side of 0. So it will come closer and closer to 0. Then I can see that it is approaching to an unique value 0. So I conclude that this particular limit exists, and limit n tends to 0, 1 by n is equal to 0. Let me take another example. Minus 1 by n square. Is this increasing?
Same, sir. This will also be convergent, but it will be convergent from the left side.
This will also be convergent, and where this will converge to?
0.
Right. So if you see on graph, but this time it will start from left side. So this is minus 1. So when I see the first term of this, just substitute n is equals to 1. That will give me the first term. So when I substitute n is equals to 1, I will get minus 1.
Minus 1.
So this will be my a1. First term in my sequence is minus 1. If I look at the second term, it will be minus 1 by 4. So just substitute n is equals to 2, you will get minus 1 by 4. So a2 will be minus 1 by 4. So if I substitute 3, minus 1 by 9, minus 1 by 9, likewise minus 1 by 16. So as I keep on increase my value n, it will come closer and closer to 0.
Excuse me, sir. Sir, is this possible that we can have a sequence that is coming from both left side and right side and converging to a particular value?
Right. Just hold on. I will give you that example also.
Yes, sure, sir.
Sir, excuse me, sir. If any number approaching to 0, then it is called convergent. Yes. Thank you.
See,
Not 0.
only the divergent cases are this.
Not 0, na? Any real number. It may
Any real
converge to
number,
0.
not only 0. Any real number.
Can you repeat, sir? What is it?
Any real number.
Yes, any real number, I agree. So if it is approaching to 0, then it is convergent.
Even 0 is a real number, so it is convergent.
Now it may approach to 0, 1, 2, 3, anything.
Yeah, anything. 0 is also included.
Real number.
Then when it is called divergent?
Okay. Divergent is when it tends to infinite or when it tends to minus infinite, or my sequence is is converging to two different values, a1 and a2. Two different values. Sometimes it is converging to 1, then when I change my value and sometimes it will converge to minus 1, like that. I will tell you an example. So now tell me this. 3 minus 1 to the power n divided by n.
Converging, sir?
Yeah, it's a convergent towards 0.
Convergent towards 0.
But from
Will it
both sides.
approach
When,
from left side or right side?
both sides, in fact.
Both
When
sides,
n is
sir, both.
odd, when n is odd
Both.
from left, when n is even from right.
Yeah, right. So if you see here, my first term will be, when I substitute n is equals to 1, I will get minus 1. So my first term will be minus 1. So this is my first term. So what is my second term in my sequence? I
1 by 3.
substitute n is equals to 2.
1 by 2.
So what is minus 1 to the power 2 by 2?
1 by 2.
1 by 2.
1 by 2. So where will my 1 by 2 be?
So on the right side between 0.
Somewhere here.
Right side.
Yeah, this is 1 by 2. What is my third term now? A3.
Minus 1 by 3.
Minus 1 by 3.
Yeah, minus 1. Fourth term is 1 by 4. Like this. 1 by 4 minus 1 by 5. Minus, 1 by 6. Like this. It will take one value right side and other value left side. Right side, left side. But if you observe, if you keep on increasing the value of n, whether it is right side or left side, both approaches to this 0. Right? From the left hand side and the right hand side, both the values comes closer and closer to 0. Now also I can say this particular sequence is getting closer and closer to one unique value, which is 0. So therefore, even I can say this particular sequence will also tend to 0. Okay. Okay. Now tell me this.
Excuse me. Could you please mute everyone and request them to remain muted unless they are speaking, please?
Okay, okay. I will just mute everyone. If you have doubt, please unmute yourselves. Okay. Now think a bit, think a while.
Convergent.
Divergent.
Divergent.
So divergent.
Divergent.
Divergent. Why?
Convergent.
Put n is equal to
Two values, minus 1 and 1.
and n is equal to 2 to plus 1.
It keeps shifting between +1 and
Yeah.
-1.
Minus 1. Yes.
So what I can see is sometimes it is taking -1 and sometimes it is taking +1. I cannot guaranteely say that it will eventually get closer and closer to 1, or it will go to closer and closer to -1. Sometimes it is -1 and sometimes it is +1. So in these cases also, even it is not taking any other values, but it is taking two different values. That means this particular sequence is converging to two different values. So I said this is a divergent sequence.
Excuse me, sir. Sir, but for every value, for every even value, it gives us +1, and for every odd value of n, it gives us -1. So it is actually oscillating between two values, and it is just focusing on two values and jumping from one value to another.
Right.
So you just discuss about a fun sequence which is oscillating. So is it a oscillating sequence?
See, this is an oscillating sequence. Converted to some particular. One second. Ashmita.
How it is not approaching to infinity, then how it is divergent?
See, because it is taking two different values. See, even if it takes two different values, also it is divergent. So our sequence should converge to an unique value.
Okay.
Unique single
So
value.
if it is converging to 0, then it's convergent. Otherwise, if it is oscillating between two values and it is approaching infinity, then it is divergent.
Yeah, divergent. See, not only 0. If I take a sequence like this, 2 minus 1 by n. So this particular sequence will converge to 2.
Okay.
Okay. But even 2 and 2 is a unique value, unique single value. So I say this is a convergent sequence, and the limit of this sequence is 2.
Okay.
Okay.
So if it either it is constant or it is converging to 0, then it's convergent. Otherwise, if it is oscillating between two values and it is approaching infinity, then it is divergent.
Infinity or minus infinity, it is divergent.
Oh, thank you.
So see these examples. One, this particular sequence n minus n and n square. These all are divergent sequences. If you see, if I keep on increasing the value of n, these sequences will either go to infinite or minus infinite. This will go to minus, this will go to infinite, this will go to minus infinite, this will go to again infinite, like this. These particular sequences are also divergent sequence because these are not converging to some particular value, or these are not getting closer and closer to some particular real value. This is going to infinite. So even in this case also these are divergent.
Sir, in sequences, n is always natural number.
Yeah, n is always natural number.
So we can put value of n to 1 to infinity.
1 to infinity.
Or we can also use 0.
No. Now we are excluding 0.
Okay, sir.
Okay.
So can we have more than one subsequence within a sequence?
Of course, yes.
Okay.
See, this
Because,
is sequence. If I take sequence 2n, this is a subsequence of this n. And 3n is also a subsequence of n.
Okay.
Understand?
Okay. Okay.
So one clarification, n is integer or natural number?
Natural number.
Not integer.
No. See.
Okay.
If you say integer, then it is positive integer.
Yeah.
What is the
if you want to say integer, it's a positive
sequence?
What is the?
I mean, what is I have not gone through the video. So what is what is the deal with subsequence? I couldn't understand.
See, subsequences are like subsets. Okay, if you have some sequence like this 1, 2, 3, 4, 5. So this is a sequence n, right? Sequence where my nth term is n. So if I consider this sequence 2, 4, 6, 8, 10, 12 and so on, only the even numbers. So this is a subsequence of, I am taking the eventh placed numbers and I am creating a new sequence which is taken from this original sequence.
Okay.
And this sequence is 2n. Okay. If n is 1.
I got it. So subsequence are subsets of n.
Subsets of some sequence.
Okay. Thank you.
So excuse me, sir. I am completely confused with this -1, the one above this one. Yeah. How it is divergent? Because once again, it's approaching to real number.
See, it is approaching to real number, but it is not unique. So it is going to two different values, -1 and +1.
So it is approaching two values, then it is called divergent.
Yeah. So those are the only three cases where we say a sequence is divergent. If it goes to two different values, if it goes to infinite, if it goes to minus infinite. So if my sequence is taking two different values, approaching to two different values, then my sequence is divergent. If my sequence is going to infinite also, then it is divergent. If my sequence going to minus infinite also, it is divergent.
Okay.
Okay. Yeah. So these are the examples we have seen of all the cases. So this is an example that where my sequence takes two different values. So that is why it is divergent. Here my sequence goes to infinite. Here my sequence goes to minus infinite. These are very simple examples. Okay. So there can be complicated examples also, but understand the basic concept behind this. So when my sequence is...
Excuse me. Any particular reason why we are restricting n to only natural numbers and not the whole of integers?
See, it's just simply we are to define the sequence. That's it. I have just given, right?
Yeah, it's part of the definition. That's it.
Yeah, it's part of the definition.
it is kind of sequence number, right? If there are 10 students, what you will give sequence number 1, 2, 3, 4, 5, 6, right? Not -1, -2. That will complicate, right? So this is just
Okay.
just an
I
index
got
for a
it.
particular position, right? Yeah.
Yeah. I was thinking in terms of the values. Now this makes it clear because
Yeah,
it is
it's a
also the index also. Yes.
Yeah, it's
yeah,
the
it's a
index.
yeah.
Thanks,
Okay.
Abhi.
Thanks.
Okay, I have one doubt here.
Mm-hmm.
In the video, it explained when it comes to the sequence of n, we can say it converges to A or it diverges to A, but we will say n as a divergent. That part is little bit difficult for me to understand the statement. Can you clear?
Sequence n.
Sequence n. It will go till infinity, na?
It will go to infinite.
Then he gave a statement. Earlier, people used to say this n converges to infinity or diverges to infinity. Both means same, but we are saying n as a divergent.
It is simply the sayings. Okay. So in the initial, when mathematics just born, we just introduced the convergent only. So at that time, people used to say every sequence is convergent, but we say this particular sequence converges to infinite. Okay, in the olden days, we consider infinite also some particular thing, and we say it will converge to infinite. But
so how it became divergent again? Because it anyway tends to infinity, na?
Yeah, it will tend to infinite. But later on, some proof, some mathematicians came into play, and they said we will call it as a divergent. Why to call it as convergent? Because it is tending to infinite.
Now we should remember it as a thumb rule. When it tends to infinity, it will become divergent.
Yeah. See, we just modified definition. So our limit definition modified to this will tend if my sequence tends to some particular real value. So when I say real value, our infinity and minus infinity will go off.
But still we will write limit n tends to infinity. Wherever we write limit, we will write that on n tends to infinity.
N tends to if n can tend to infinite, our sequence shouldn't go to infinite.
Okay, fine. Thank you.
Okay. See, n is equal to infinite is different from n is tending to infinite. Okay.
Yes.
So this is not valid at all. N cannot be equal to infinite. N can only approach to infinite. Even the largest number is very smaller than infinite.
Okay.
Much smaller
See,
than
when it comes to our log functions, asymptotes, it will approach us to 0. It will never be 0.
It will never be 0.
Can we consider these asymptotes as this convergent?
If it is, asymptotes, if it is taking
Always
the real value.
Asymptotes approaches to 0, but it never touches 0. That's what we consider it as a convergent.
Yeah, it is convergent. See, even here it will never take 0. It will just approach to 0.
Yes, approaches to 0.
Yeah, approaches to 0 is okay for us. So that is what we said. In the definition also, an should go closer and closer to a, not equal to a. If it is going closer and closer to a, we say the limit exists and that will be equal to a.
Okay, fine. Thank you. And that part limit exists or not, we will approach from left, approach from right. Whether if left equals to right, then we'll say limit exists. That is also, can you please clear that after this?
Which one?
Limit exists or not. He said limit from when we approach from left side and when we approach from right side. If limit both are equal, then only limit exists, like that he explained in the video.
That is function. We have not started looking at the limit of a function.
Okay.
We are just dealing with sequences only. We are now in sequences only. So that will come when we talk about limit of a function. I will just within 5 minutes I will start.
And so
one more thing.
Exist or not, how we will say limit exists or not?
This is how we say if the sequence is divergent, limit does not exist.
Okay, fine. Thank you.
Yeah, if it is existing, then I can write it like this. So limit exists and the value is like.
Sir, in case of asymptote, sir, in case of asymptote, that whole thing is going towards infinity, no? So that would be divergent, although it is approaching zero.
Okay, if
but
it is
in the end,
okay, I
it's
got you.
never going to come to zero. So that would be, I think, divergent, no?
No. See. If it is approaching to infinite, then it is divergent. But here, log cases, log function will be like this, right?
Yeah.
When x tends to 0. Okay. This will approach to minus infinity, you are saying.
Yeah, mine is also seemed out, but I couldn't convey properly.
The vertical asymptotes will always be divergent, I think.
Divergent, yeah. Vertical asymptotes will be divergent.
And horizontal
Horizontal
asymptotes will be convergent. Yes, sir.
Okay. So, okay, I have a sequence e power minus x. How will e power minus x look like? Not e power minus x. Okay.
So you can take 1 by n.
It's e power minus x only, no issue.
So this is the graph of e power minus x, right?
It will go towards 0.
So I say I will just take e power minus n. So when I say e power minus n, my n will take values from 1, 2, 3, and so on infinite. Okay. My first term will be 1 by e. When I substitute n is equals to 1, my first term is 1 by e in my sequence. Likewise, 1 by e square, 1 by e cube, 1 by e power 4, and so on. Okay. This will eventually go closer and closer to 0.
Yes, sir.
Yes. Also, if you see here, e power minus x has an horizontal asymptote, y is equals to 0. Yes. Correct? Wrong? See, what is the asymptote of this function e power minus x?
Y equals to 0.
That would be 0.
Yeah, y is equals to 0. Even if I compute the limit value of this sequence e power minus n, I am getting 0.
Right.
So that means if it is horizontal asymptote, if my function has an horizontal asymptote, then I can say that particular function will actually tend to the horizontal asymptote value. Whereas vertical asymptotes will diverge, will go to infinite.
It will go to infinity.
Yeah.
Sir, one more time you say, sir.
One more? Again?
So, inclined asymptotes will also tend to infinity, right?
Inclined asymptotes. Why
Yes,
are you dealing with inclined asymptotes? Did we deal?
No, not yet.
As of now, don't worry about inclined asymptotes.
Can
so
you
only we have horizontal and vertical asymptotes. Vertical asymptotes will diverge to infinite or minus infinite. So limit will not exist at that particular point. But for horizontal asymptotes, you consider the limit value will be equal to the horizontal asymptote value.
Okay.
Fine. Yeah. One more time is like the same thing. If I have a horizontal asymptote to any function, y is equals to k is the horizontal asymptote, then my limit value of that particular function will tend to k. So whatever the horizontal asymptote is, my limit value will also tend to that particular value.
Right.
But it is not true for vertical asymptotes.
Actually, sir, the horizontal asymptote is the value of the function, right? That is the y-axis actually. So it will always be the y-axis is our value, right? The other thing would be the domain. So domain to kuch bhi ho sakta hai, right?
Right. Yeah. Correct. Okay. So these are about limits of a sequence. So once we have seen the limits of a sequence, now we will deal with limits of a function. So now we are getting into functions. So I have a function which is defined on some domain D to some codomain C. Okay. If I wanted to find whether limit value exists at a point x is equals to a or not. So where my a can be inside domain or outside my domain. So a can belong to D or a may not be in D. Okay, observe this. I just wanted to find whether my function will approach to some value when x is approaching a. So not equal to a, is approaching a. So simply the same as sequences only. So same as sequences, limit of a sequence, here also the same thing, but we are worrying about some particular point. We are not worrying about when n tends to infinite kind of cases. We are just worrying about my function value, my domain value is approaching to some value a. Will my f of x approaches to some particular point? So simply we are checking when x is tending to a, whether f of x tends to some particular value, oh let's say b or not. So if it is tending to some unique value b, I say limit of this particular function exists at x is equals to a. If it is not tending or if it is not converging to that particular value b, that means if it is going to two different values or if it is going to infinite or if it is going to minus infinite, then I say this particular function will not have a limit at x is equals to a.
But here my doubt is how many points we should check to tell the function is convergent or divergent.
No, we don't talk about convergent of a function.
Sorry, limit.
Okay.
How many points we should take?
No. Even the limit also we will not worry about limit of a function. We don't talk about limit of a function everywhere. When I say limit of a function at some particular point.
Okay.
We will talk about at
we won't
particular
define for the entire. Now you said now for the function. That's what.
Okay.
At a turning point, no sir.
Not at turning point. Limit of a function at a point.
Okay, fine. And just now we went to the statement that if x tends to a, if x tends to b, then we will say the function.
This particular a, we are worrying about at some point a.
So we can define limit of a function in the local region only. Not
in the local region only, not the entire. We don't say limit of a function. We say limit of a function exists at every point. So this is how we say limit of a function exists. This is not a valid statement of saying limit of a function exists. We say limit of a function exists at every point.
Particular point or every point?
If it is satisfying for every point, we say every point. If it is not satisfying for one particular point, how we will say is limit of a function exists at every point except at these values, except at some x is equals to 2, x is equals to 0. If the function doesn't have limit at some points, we will ignore those points and we say except at those points limit exists at every point.
How to know these points you will explain now?
I will explain how to know these points and how necessary to check one point and is it necessary to check some points or not, we will see.
In the video,
Sir, I haven't watched the videos, so it is kind of getting over my head. First time I'm going through this, but
so please explain it to the sin x function, no, the limit concept. In case of a function.
Sin x.
Sir, can you explain
with the sin x or a cos x function, if you can explain? No? So that
Yeah,
limit
sin x and
in
cos
the
x are
case of a
actually
function.
continuous.
Bounded function adna.
Floor function, it's explained. It will be better with the floor function only.
I don't take that complicated floor or I don't take sine. I will just simply take some.
Yeah,
Not
that's
simply.
better, sir.
I
Yeah.
will take a good function where you will understand. See now
What
my f of
functions you used to give in the exam, that function you take.
no.
So one clarification.
Yeah.
Excuse me. Where A does not belong to the domain, I don't know, in that for that A, the function will not be defined, right?
Function
Yeah,
is
so
not
that would
defined,
be
but
the
limit may exist.
limit will be, yeah.
I will
Like
take that
yeah.
particular example only.
Yeah, yeah. If I see the graph, then maybe I understand.
Maybe you
Okay.
can. See, I am taking mod x when x belongs to real minus 0. Okay. And I am not defining when x is equals to 0. As of now, I am not defining. So simply for this, I can write it like this. It will take x when x is greater than 0. It will take minus x when x is less than 0. Okay. So
Yes,
this is
sir.
how the mod x will be, right? If I split it, this is how it will look. It will take x when x is greater than 0. It will take minus x when x is less than 0. So if I draw the graph of it, note that I didn't define my function at x is equals to 0. Okay, this is how I defined. Okay, this is my function. So I didn't define at x is equals to 0. Now I will try to plot that particular function. So I know my f of x is x when x is greater than 0 minus x when x is less than 0. So it is x. So simply it is x. So when x is greater than 0, this is how it will look like. So when x is less than 0, it is minus x. So the minus x graph will be like this. Right? At 0, I didn't define. So at 0, there will be an open hole. So open hole indicates that function doesn't take value at that particular point.
Okay, we are interested in where the function is approaching rather than the exact value. So
yeah.
So if it is, even if it's not defined, it does not matter for us.
It does not matter.
Yeah.
Okay. Thanks.
Now I wanted to find whether limit of this particular function f of x exists at 0 or not. So that is my worry.
Here, my one doubt is why you kept open circle.
Open circle is because I didn't define function at that particular point.
We don't want to define, but actually mod x will be 0, 0, na?
I said right, this is my function.
Okay.
They have
fine,
excluded, right? 0
Just to illustrate that point.
Yeah. This is my function. This is not mod x function. This is my function.
Okay, clear.
Okay. So, yeah. Now, I just wanted to find whether this function limit exists at 0 or not. So in order to check that, what we do is we will approach. So I am worrying about x is equals to 0 point. Right? I wanted to find whether my functions have a limit at this particular point x is equals to 0. What I have to check is I have to approach this particular value 0 from left hand side. Left hand side means 0. Left side of 0 is this. So I will start somewhere from here, and I will approach to 0. And also I have to start from right. I have to approach 0 from the right hand side. From the right hand side is I will start from this value and I will approach to 0. Approaching to 0 means I will start taking values of x from this point and closely move to 0. And I will look at the function values of those. So let me say I will start from -1 and +1. -1 from the left hand side and +1 from the right hand side. So what I have to do is limit. I have to check my x is coming from, when I say 0 minus, this indicates me that this x is approaching to 0 from left hand side. So minus is the values are lesser than 0. So 0 minus values are lesser than 0, which tells me that this particular x are negative values, and which tells me that this particular x will approach 0 from the left hand side. So this thing, when I say x tends to 0 minus, I will check where this function f of x is going. Whether this limit is existing or not is my first question, and my next question is, if exists, where this is, what is the value of that limit. So I start, as I said earlier also, I start taking values from -1. So here -1 is my first term. So I will start putting x is equals to -1. So my f of x will be minus of -1, which will be 1. Now I take minus 0.9. So my f of x will be minus of minus 0.9, which will be 0.9. So if I take x is equals to some minus 0.3, so I should approach to 0. I started from -1. I just have to approach, I just have to come closer and closer to 0. So -1, minus 0.9, -3, -0.3, -0.2, -0.1. Likewise, I will approach and I will look at the function values. So when I am looking at the function values, so this is taking 1, this is taking 0.9, and next it will take 0.3. If my x is minus 0.1, my f of x will be 0.1. Like this 1, 0.9, 0.3, 0.1, 0.005, 0.00001. So I can see that my f of x function will come closer and closer to 0 when my x is coming closer and closer to 0 from the left hand side. So I can conclude that this particular sequence is converging to value 0, right? This particular sequence, now the sequence is f of x. So this particular sequence will converge to 0 when I come closer and closer to 0, when my x takes closer and closer to 0 from the left hand side. So therefore I can write it like this: limit x tends to 0 minus f of x will tend to 0. Okay, this particular left side tending, I call it as limit L, left side, LL. So it's just the notation. Limit value LL is the limit value.
LHL, sir. LHL.
LHL, sir.
LHL.
Yeah, left hand limit.
Yes, sir. Left hand limit.
Okay, LHL, whatever. It's just the denotation. Okay, if you want to keep it LHL, LHL, left hand limit. Okay, HL is in subscript or like this.
Yeah, like this only, sir.
Okay, so this is LHL. I'm not that fond of capital letters. I just wanted to take simply like this.
Okay. Maybe, sir. Yeah.
Okay. Yeah, this is just the value of this particular limit when it is approaching from left hand side. So how we approach is take some value, start from some value which is on the left hand side, which is -1, and start coming closer and closer to 0. While you are coming closer and closer to 0, look at the values of the function. If it approaches to some particular unique value, then I say the limit exists. If it is diverging to infinite or minus infinite, or it is taking two different values, then I say limit does not exist. So I conclude limit does not exist. Left hand limit does not exist. Okay, if it exists, I say I can write it like this, and I just denote it with left subscript L. Okay, same thing goes from right hand side also. Right hand side is x tending from 0 plus. Plus denotes me that x is approaching from right hand side to 0.
Okay.
Okay, I will just check whether this limit exists or not. Similarly, I will start from 1. It is not mandatory to start from 1. You can also start from 0.5 or 0.4, but it should be, the value should be right side of your 0. Once you fix your first point, just start coming closer and closer to your 0. Okay, so I started from 1 here. When x is 1, my f of x is 1. When x is 0.5, I should come closer and closer to 0. So when x is 1, when x is 0.5, when x is 0.3, 0.2, 0.1, 0.001, likewise I will check. So when x is 0.25, when x is 0.1, when x is 0.0002, like this, I will just look at the function values. So this is 1, this is 0.5, this is 0.25, this is 0.1, 0.002. It will keep on decreasing and it will come closer and closer to C. Here also you can simply see that, right? So this is the background. See, this is what happens in the background. So I can simply conclude that even from the right hand side, even if I approach from the right hand side, my function value will approach to 0. So therefore the limit of this function from the right hand limit exists and it will be equal to 0. And I will just simply denote it as L subscript R. Okay, this is left hand limit, this is left hand limit, this is
Sir,
right hand limit.
sir, if left hand limit is not equal to right hand limit,
then limit does not exist at that particular value.
Yes, yes.
Okay, now I will
Suppose, suppose instead of x equal to 0, if we take x equal to say some value 2, so how it will again will approach at 2 from right side of 2, say from +3 and from 1 towards 2.
Yeah, right. So if it is something like this, okay, so here at x is equals to 2, I didn't define my function. How I start checking is, so if I wanted to approach from left hand side, so I will start from something 1. So 1, I will start moving
1 minus and 1 plus.
Hmm?
No, 1 minus 1 and 3.
1 and 3 or 1.5 is also sufficient. 1.5 to 2.5.
Plus,
I just said 1 and 3.
Excuse me, sir. So here we will say that x approaches to 2 and the superscript we will put a minus or plus.
Minus. See, this is limit. For this I am writing this. Limit x tends to 2 minus. When I say 2 minus,
yes sir,
x is approaching from x is approaching to 2 from left hand side. Left hand side. This minus denotes me comes from the left hand side. Plus denotes me that x is coming from
the approaching from right hand side.
Right hand side. Yeah. Whatever the value may be, whether it is 0, 2 or so at A. I wanted to check at A. It is at A.
Just by looking at the graph, can we judge at that point?
Sure.
The limit exists or
Just by
not?
looking at the graph, you can judge. See, this is what happens in the background. Okay, I'm just explaining you how this works.
Yes.
And simply now once you got the left hand limit and the right hand limit, both should exist first. Okay, either of the limit does not exist, then I will conclude that limit of that function at that particular value x does not exist. No need to check for the other.
Like we also like to see the value at the point.
No, we don't worry about value at that point. That comes when continuity comes. That comes. Okay. As of now, don't need to worry about what the function value at that particular point.
Okay.
Worry about
when we are looking for
my function value tend when I approach from left hand side, and where my function value will tend when I approach from right hand side. If now we will come to the definition. If L is equal to LR, then
limit exists.
Limit
exists.
Limit of function
at a point
at x is equal to a exists. I just said a because any point. Here it is 0. It can be 2. It can be 1. It can be any real number. If my left hand limit and the right hand limit are equal, then I will conclude that limit of the function of that particular function at point x is equals to a, or here x is equals to 0 exists. And the next thing is, if LL is not equal to LR,
limit does not exist.
Limit does not exist. Okay, this comes in the case of limit taking.
X is equal to 0 means we have to.
You are saying something, Guru.
Yes, sir.
Limit doesn't exist at that particular point.
At that particular point, limit does not
Yeah,
exist
at
at
that
x is equals to
particular
0.
Okay.
Okay, yeah. Limit of function.
The graph you have plotted is I didn't get it, because the graph should be x-axis, na? Because if you increase the x, the value going to 0. So I think it should be x-axis graph.
What is x-axis graph?
Means the graph should reflect like a x-axis, because for every value of x, the value is going to 0.
For every value of
Because x is greater than and x is less than 0.
Mm-hmm.
It is going to
plot the
x.
graph. See, you know y is equals to minus x graph.
Yeah. Y is equals to
How it will be?
It will be in second quadrant.
Second and fourth, right?
Yeah.
But I am defining that minus x graph only when x is less than 0. I am just restricting that. Okay. It should be whole this line, but I am worrying about only x less than 0 thing. So when x is less than 0, it takes only minus x. That means my graph when x less than 0 is this. When x is greater than 0, it is simply y
I
is equal
understood his doubt. I understood his. We defined here x greater than 0, right?
to.
So as 0 is going to infinity, the function of the value is also going to infinity, na? Function value, f of x.
As x tends to 0.
X goes to infinity.
As
X greater than 0, we wrote as x greater than 0. As x is going to infinity.
Yeah, that is what this.
F of x is going to infinity.
Right.
That's what his doubt, I think.
Is that your doubt?
Yeah, means because we are discussing here for a value between 0 to 1, everything will go to 0. So from that perspective, I am thinking it is y-axis. But when I see the function, now I think it should be like this, what you have plotted. But if you go by that concept, because the graph was not visible, I joined in between. So I thought it should be y-axis then. So that's how that confusion has come.
Okay. No. So this is correct. So just go back a few minutes back in YouTube and just watch again.
Here for this function, we are checking at the point 0, the limit exists or not.
Yeah, at this particular point. So what we got is limit exists, because my left hand limit and the right hand limit both are tending to 0. From the graph also I can see this particular function is approaching to 0 from the left hand side, and from the right hand side also this is approaching to 0. From the graph itself I can see that both the left hand side and right hand side limits approach.
Vicky, before erasing this graph here itself, can you explain about tangent exist for this or not?
Sorry, I am Srikanth.
Tangent, sorry, Srikanth. Tangent exists for this function or not?
Tangent at point?
For this graph, for this f of x. Tangent take any point, because it looks like straight line, no?
Yeah, see, that is what I said. Don't need to worry. Don't worry about tangent for a straight lines.
Okay.
I already said that is a debatable topic, and we don't worry about tangents if they are straight lines. We will worry about tangents only if the function has degree more than 1. So we will start looking at the tangents from quadratic functions.
Okay, thank you.
So tangent at point 0 and 0 is for this function, this particular case.
Tangent at
0.
Origin is not even defined.
Not possible.
Talk about
Sir, there is no tangent for a straight line, they say. Is it?
if right hand limit and
Sir, at
left hand
any
limit
point,
is
a
equal.
straight line is itself a tangent.
Exactly. Yeah.
Uh,
So
right hand limit and
what
left
can we
hand
say
limit.
But
about
in
a
this
tangent?
function, tangent is not defined.
It doesn't exist for a straight line. I mean, everything is a tangent. Every point is called a tangent in a straight line.
So that is why I say, don't think about that.
And what about continuity? At point 0 it is because left and right hand limit is equal, so it is continuous function, right?
Do I have to discuss continuity here itself? It's from week 8 topic, right?
Yeah.
So we
Sir,
will-
in the red graph only, we have seen limit at x equal to 0, right? So
Yeah.
suppose instead of x equal to 0, we are say at 1.5. So at the 1.5 value of the function will be 1.5. Limit at 1.5 will again be 1.5, right? Because it will be going towards 1.5 from both directions.
Right.
Okay.
When
So
we
in this line, whatever is the value of fx, that will be the limit at that particular point.
See, when
Here
we
in
talk
our lecture, this word periodic function, oscillating function, these words came.
that is about the sine, cos.
Yes.
So one more thing, sir. There are many complicated formulas that have been given in the video. So how do we go about that, sir?
Formula for what?
So in case of limits only, in the last or the second last video, there are many formulas which have been given, where sir has said that these are black boxes which you need to just take it as it is without
Formulas.
getting into.
Those are E.
Yeah. So
exponential.
there is a page full of formulas. So how do we go about that?
Go about that is just simply.
रटना पड़ेगा.
Yeah.
Memorizing.
Yeah.
I mean, you can
basically
practice
remember
questions
this
when
simpler one.
एक्सपोनेंशियल बाइनोमियल में भी रटना पड़ेगा.
रटना तो पड़ेगा.
हाँ, इनका तो प्रूफ भी बहुत ही बड़ा है भाई.
And this one is okay. Another one is there with some. Yeah.
Actually, this function we have been studying in some other place also, right? So maybe we have studied somewhere else then.
It's familiar for us. We
Yeah.
learned this. This is okay.
And this is very easier one, I guess. This one.
Yeah.
And
Sir? Sir, in this particular courses, we have to know about trigonometry?
Not much. We don't need the complicated functions of sine 3a, sine 3 theta or cos 3 theta. And what are the values of sine 60, sine 45? We don't need much of it. Just understand the graphs of. Understand the graphs of.
My doubt also. There is no need, right, to
No.
remember all these values.
No.
Sir, ITF.
If necessary, we will give it as a note in the question itself. Note sine 60 takes the value √3. Okay. Or sine 45 takes 1 by √2, kind of thing. Okay. So these are okay. Just remember some 4 to 5 limit values, and one known well-known limit value is 1 by. So where will this limit go?
And limit extends to?
What is the log thing? I just forgot. Even I am bad at remembering formula.
Log is not there. Here we have 4 formulas, e power x only. One more sequence is n by nth root of n factorial. Nth root of n factorial. This will converge to e. E. And one more is there, n in the bracket, n in the bracket, square root of 2 pi n by n factorial whole power 1 by n. This converges to E.
Okay. And also you have one graded assignment question, I hope, involving this.
One more is there with sum of k equals to 0 to n x power k by k factorial. This will converges to e power x. That is the new one.
Okay, see, that is just the expansion of e power x. E power x can be expanded to 1 plus 1 by 1 factorial plus
okay.
x by 1 factorial plus square by 2 factorial.
This 4 only we have in the lecture.
So this particular thing I can simply write it as when I is equals to 0 to infinite x power I by I factorial, or when if I can write it there, k x power k factor. This is just the expansion of e power x, and also you have the expansion of 1 by 1 minus x, I guess. Just look at the expansion of 1 by 1 minus x also. Okay, and yeah, see, for these things you just have to remember, or you don't need to worry about these particular things. Okay.
अभी मैं इसी के बारे में पूछना चाह रहा था.
Okay, don't worry.
Right, sir.
See, if you have given question on this, I say graded assignment mein we have given, right, limit of some important limits bolke we will give this.
Yes, sir.
If it is necessary, we will give this. No need to memorize or something, but just take a look at it, try solving some 2 or 3 examples, that's enough.
Okay.
Okay. Yeah, okay. Okay then. See, this periodic is, if you see the graph of sin x.
And Srikant, one more doubt. Do we need to remember these graphs, sine, cos, tan, cosec, or is there any other way to know easily?
See, sine, that is why periodic is important. See, if you can draw in the interval of 0 to 2 pi, it's just the multiple of, you just multiply that same graph left hand side and the right hand side. Okay. Just then it will increase, sin x will increase first. You know this thing, right? Size all silver teacups kind of thing.
No.
In which quadrant sine will be positive, in which quadrant tan will be positive?
All sine, tan, cos.
All silver. Just remember like this.
No, can you please explain?
Okay. These are some 4 quadrants. Just take this as some 4 quadrants. And remember this sentence, all silver teacups. So when I say all, you have to write it like this: first quadrant, second quadrant, third quadrant, fourth quadrant. This all
ASTC.
ASTC, the same thing. If you wanted to remember it as statement, remember like this: all silver
All
teacups.
positive or sine positive, tan positive, cos
positive. So all means every sine, cos, tan, cot, cosec, secant, everything will be positive in this quadrant.
Yes.
Okay? And in the second quadrant, sine, silver, sine will be positive. As sine is positive, cosec is 1 by sine. Cosec will also be positive. Here comes t. T means tan. In the third quadrant, tan will be positive. Rest all will be negative. And final quadrant, fourth quadrant, cos. So cos and secant will be positive. Rest all will be negative. So once you know that in the first quadrant is from 0 to pi by 2, 90 degrees. So in this 0 to 90, sine is positive. In this 90 to 180 also sine is positive. That means my function should be positive side or above x-axis in the interval 0 to pi. So 0 to pi, sine is positive. Sine should take positive values.
Can you explain again? 0 to pi by 2. Can you explain this?
This particular
with the axis.
This particular first quadrant will take will have 90 degrees, right? 0 to pi.
Yes.
Pi by 2 is 90 degrees. So in the first quadrant from 0 to 90 degrees, sine will take positive values.
Okay.
Right? This is 0 to pi by 2. And you know sine pi by 2 value is 1. Sine 90 is 1.
Yes.
And sine functions and cos functions will oscillate between -1 and 1. So
Yeah,
maximum
-1
value,
and 1, right.
maximum value of sin x is 1 and minimum value of sin x is -1.
-1, right.
So once it reaches the maximum value 1 at pi by 2, it will again decrease to 0 at pi. Now you see in the second quadrant also sign is positive. That means pi by 2 to pi also sign should be positive. So this is how you draw the graph. So from 0 to pi the sign should be sign graph should be above x-axis, and from pi to 2 pi you see below third quadrant and fourth quadrant will come. In this
Negative.
quadrant sign is negative, so sign will take negative values.
Pi to 2 pi.
Pi to 2 pi. So once you have drawn from 0 to 2 pi graph of sin x, you just repeat the graph. So you just repeat this thing again and again.
Sir, these are oscillators, right?
These are the oscillating functions. These functions will oscillate in between -1 and 1. And you see periodic functions are the same thing which I said. So if it is repeating in some particular interval, it is
Square wave also repeated, no? Square wave.
Which wave?
Square wave.
What is square wave?
Is a rectangular signal.
What is this thing?
This one also.
Okay. So I don't know this square thing.
Okay.
Okay. So yeah, once you know how to draw the graph of sine or cos functions from 0 to 2 pi, it's just the periodic of it. The same thing will repeat again and again. So we say these functions are periodic, which periodic functions which has period 2 pi. Period 2 pi is like there is a repetition after every 2 pi intervals. Okay.
Do we need to consider anything about symmetry of y-axis here, or any side is okay?
No, any side is okay. See, this is not symmetric about y-axis. Cos functions are symmetric about y-axis. This is not symmetric about y-axis. See, if you if you invert this particular thing will come above.
Yes, sir. Sir, if we take mod of the sin x, then it will symmetric about
Symmetry comes here. That's
mod
what
sin x. Yeah, mod sin x is simply periodic of pi. That will be like this.
Yes. All
Sir,
negative
tan period is pi, no?
Tan period is
period of tan.
That will be 2 pi, right? Pi, right? Minus pi by 2 to pi by 2.
Yes.
Yeah, pi. Okay, but the idea is
where it touches the x-axis. Can we say that is as a period?
Period is when it is starting repeating itself, right, in an exact manner. That is the period.
So this particular sin x will start repeating
after 2 pi, right? Yeah. So that's why it is a period.
See this thing.
0 to pi, 2 pi, they are all periods.
No, 0 to pi, like sign is not repeating itself, right? It is going from pi to 2 pi, it is
0
going
to 2
negative.
pi, and then it's repeating once again. It keeps on. That is the period. I'm explaining that.
Yeah.
See this.
No, for the tan, you said pi, na? That's what.
I will draw the tan graph also. Just observe this particular shape has an sleeping S shape, right?
Yes.
Kind of thing. Okay. This particular
same pattern should repeat. The period.
Same pattern will repeat for every 2 pi. So that is why this particular sine graph has period 2 pi. If I draw the graph of tan x, for tan x the graph will the graphs will be like this. So this is pi by 2 minus pi by 2. This is 0. This is pi by 2. This is pi. This is 3 pi by 2. And this is minus pi. This is minus 3 pi by 2. So this is how the tan graphs will look like. So it will increase from minus pi by 2 to 0. And again it will be like an x cube kind of thing. So if you can remember the graph of x cube, the
Yes,
same,
sir. Same.
the same will
Yes,
be
sir,
this.
X cube.
But this will be in the interval of minus pi by 2 to pi by 2 only.
Sir, there is a vertical asymptote minus pi by 2 x pi by x equal to pi by 2 is vertical.
Right. So these are our vertical asymptotes for tan graph. Okay. So you see this particular pattern, this particular shape pattern is repeating after every pi. So you see minus pi by 2 to pi by 2 is of interval pi only. And this shape is being repeated in every pi intervals. So as this is repeating within the pi intervals, so we say period of tan is pi.
Sir, mod of 10x graph will, sir, how it will look like this?
Don't worry about mod of tan square.
No, sir, no, sir. Sir, please.
See, just simply invert it, na. Mod will become negative values will become
ये 80 वाला ऊपर चला जाएगा.
That's it.
Okay, sir. If we take 10 of mod x, then
tan of mod x. Okay. As you are asking these many questions, I will try to include 2 or 3 questions in quiz 2.
Just one second.
This is a complicated question where it involves a step mod and floor
No,
and everything.
sir. Actually, for the graphs, the best thing is Desmos, right? You whatever comes in your mind, put it there.
Just
you will
put
know
it
how
in the
it looks
Desmos
like.
and try it out.
Yes,
That
exactly.
is the best thing. Yeah.
Where are we? I mean, are we nearing conclusion of week 7?
Done, right? The last
Okay, I was
lecture
waiting
of
for
week
that
7
actually.
Okay, last lecture of week 7 is how we find the limit of a function at some point. And
Okay,
in the
okay. Thank
next week we will discuss continuity, differentiability, and everything.
Okay, thank you.
Okay, yeah.
Thank you,
sir.
sir.
We are done.
I had a doubt about logarithmic equations, so if that's cleared, I'll probably leave in a while.
Yeah.
Yeah. So I put this question in the forum also. Suppose we have a function like log of x square, not function, sorry, equation like log of x square is equal to 2.
Week 7 is completed, sir.
Week 7, as far as important topics, I have
I have
covered.
completed this much only the syllabus for week 7.
Yeah, these are the syllabus for week 7. Just go back to the lectures and come back to this session again. Just watch.
I can leave the session.
Huh?
I can leave the session.
Yeah. Everyone can leave the session, and thanks for joining.
Okay.
Thanks, sir. Thanks. That was a great session, sir.
Thank
you, sir.
Thank you, sir.
Yeah, those who have small doubts, just wait. I will take some 10 minutes. And those who are done,
Thank you, sir.
Yeah, thanks. Yeah, log x square is equal
Yes, sir.
to 2.
Is equal to 2. So now I can solve this as 10 to the power 2 equals x square.
X square is equal to 10 to the power 2. Yeah. Okay.
Which means that x is equal to plus or minus 10.
X is equal to plus or minus 10. Right.
And for both these values, since we're squaring it, the domain should be fine, right?
Yeah, fine.
Yeah, but if I take it as 2 log x instead.
Right. When you are taking 2 log x, you are not supposed to write 2 log x to the base 10. You are supposed to write 2 log mod x to the base 10.
Oh, okay. So if I take a power outside, like any even power outside, I have to make it mod inside.
Mod, yeah.
Yeah. So both ways, I'll have the positive and the negative values to be valid for the domain.
Right. So log x square will be equal to 2 log mod x.
Okay. Yeah. This was my doubt. Okay. Thanks for clearing that.
Yeah. Thank you. And don't worry about the graphs of tan, sine, cos in much detail. Just worry about tan x, sine x, cos x.
Sir, I have a doubt.
Yeah.
So, question 8 of lecture 3 assignment.
I have a doubt here in tan function. Can you clear and move because it's here on tan?
Yeah.
Can you show the graph of tan?
Right. 1 second.
Yeah, in the lecture he draw till pi only. The above part is not drawn. Is there any difference? Left hand side, both hand side, pi and minus pi is there, na?
He might have drawn.
Till, yeah, that's what my doubt.
He has drawn till there itself. If you wanted to continue, that graph will look like this.
Okay.
And if you wanted to continue further, that will be same like this only. same these inverted S shapes will come for every pi intervals. So the interval will be pi here.
Sorry to call you Vicky because your both voices are similar.
Okay, fine. I am just kidding at that. I'm sorry. I'm sorry.
Voices are actually similar. That's why.
Okay.
Thank you.
Okay, thanks. Okay, and two more
Sir,
doubts.
I have a doubt in the graded assignment question number 1.
Okay, someone asked something lecture 3, question number 8.
Yes, sir. Question 8 of lecture 3.
Week 8, right?
Yes, sir. Week 7.
Sorry, week 7.
Yeah.
I will just open it. And the other doubt is graded assignment.
Assignment question number 1.
Week 6.
Yeah, I have a
Yes.
doubt also in week 7 activity question.
Week 7 activity question.
Activity
Yeah.
1, last question.
Okay. I will take these 3 questions and we will end this session here and we will meet on Sunday. Okay, is that fine?
Yes.
We requested for any extra additional session.
Yeah, we are trying to take because see,
Actually,
we are
to revise entire syllabus in one session. That's what.
See, as we have in mathematics for data science 1. So yeah, even I am not the complete instructor. Even I work for statistics 2 in second term. We are trying to arrange one session.
We have the sessions now, but it's not like complete revision. It's doubt clearing session. No?
Right. Yeah, many of you have asked for extra sessions. We are trying to find some time. One of
Week
the
7 is okay. Easy to understand. Week 6 I troubled a lot actually. In
Yeah,
week
week
dogs,
6 is
log,
very
E,
difficult,
A,
sir.
everything.
Week 6, we are not able to get the concepts correct, sir.
Correctly, yeah,
Yeah.
sir.
Exactly.
Well,
And
even
one
for
more thing-
activity questions, we struggled a lot.
very badly. And one more thing,
Yeah.
sir, actually there is a CT is conducting extra sessions to Telegram,
Right.
doubt clearing sessions.
Yes.
And
So,
it is really
for-
good and effective.
It is very
sir.
helpful. Yeah.
And why don't you also do that, sir? So that we have
Just
extra
now,
sessions.
I just mentioned, right? Depending upon the availability of instructors and time, we should arrange
We
the
have man hours constraint.
I understand, sir, but we need extra sessions because
right. We
sometimes maths is like so difficult. It is not difficult if you understand the concepts, but we are I have finished my BTech in 2006, so I'm struggling so hard even now to understand some concepts. I have to go deeper. So
Still, I have many
extra help.
doubts in week 6.
Excuse me.
A4X,
Yeah.
E4X, many doubts are there still week 6.
Yeah, excuse me, ma'am. You were discussing about this Telegram group, but I am not in that group. How can I join that group?
Many people have given in forum and any other groups. You just can check it out somewhere.
Okay,
because,
in this
it's been
seat-
officially sent by the IIT Madras team.
Yeah,
Okay,
in
so
the
I would
mail
have some-
we also got the mail about it.
Yeah, we got a
When
mail
did-
about it.
When we received the mail, around which time maybe?
I think in the
I think
first
1
few
month
weeks.
back. Yeah.
First week. You can check the first week mails.
Okay, ma'am. Okay.
Or
okay.
what you
And
can
what
do?
is what is
What you can do this like in CD session, you can ask for Telegram link. They will provide you a particular.
Okay.
Okay, what is the
And what
question
is
number? One second.
Yeah. Please go
Let me
ahead.
complete my things. Only.
Yeah.
What is the question in AQ1, week 7?
Yeah, last question.
7th one.
Yeah.
So in which intervals this function is increasing, decreasing? Is that the question?
Yes, sir.
Okay. So what is your answer, your take? So
function is x plus 1 by x, right? Not increasing while. 7.1 activity, last 11 question.
Is it like W-shaped graph is given to you?
Yes. Not W shaped.
Okay, last question.
Yeah.
Okay, consider the function f of x is equals to x plus 1 by x.
Right.
Which of the following options are correct?
Yeah. In Desmos, I'm using Desmos and
okay. So what do you get?
Like I'm not getting the right answer, so
That is
I
why.
don't know
What
how
is
to.
your answers? What are your answers for this?
I marked surjective function for domain f is.
Surjective function. You marked it surjective function.
The answers are injective function for domain of natural numbers and injective function for domain integers except 0.
Okay. When you are saying surjective, that means your codomain should be equal to the range, right?
Yes.
Here it is given that the function is from R to R. So you should take it from this week onwards. If it doesn't mention you anything regarding the function, you just take function is defined from R to R.
Okay.
Okay. So once you are taking from R to R, that means I should get my range as real number. Set of all real numbers should be my range. Right? Okay. Now let's just check only option 5 and 6. It says that the domain of, if the domain f is, now I am restricting my domain to natural numbers. Okay. And codomain of f is rational numbers. Now tell me, is 0 a rational number?
No, 0 is not a rational.
0 is a
not a rational.
Not a rational number. Okay, one is a rational number.
Yes.
Yes.
Okay. So 1 is a rational number. So what is the definition of a rational number?
I
Is
don't
one a
confuse
rational number?
irrational.
Can you clear me? Is one rational number? 0 rational number?
0 rational number, yeah.
It includes in all real numbers.
But
See.
0 by 0 is undefined, no?
Yeah.
Okay, that is why you shouldn't read. You shouldn't read too much. Sometimes. Every time I urge you, don't go in deep in everything. See, 0 can be written as 0 by 2.
Okay.
Yeah, right.
0 is a rational. 0 is a real number, and 0 is a rational number. 0 is a natural number. 0 is an
Sir,
integer. 0 is
everything in the real number is a rational number.
No,
Real
not
num-
everything in the real number is a rational number. Every
Okay.
rational number is a real number.
Because real number also contain irrational number, right?
Oh. Real number also contains irrational numbers, right?
When you asked for the 0, I was thinking that only 0 by 0 is
No.
undefined.
Same here. I also thought 0 by 0.
In the rational number, we write
Again, I am suggesting whatever the contents we are discussing, just read there. Okay, don't think too much, because see, sometimes even if I, not only me, even if the professors, if they read too much, sometimes they make silly mistakes in calculations. Everyone will do.
Right.
Okay, so be clear about basics. 0 is a rational number. Don't worry about that. So now, as 0 is a rational number, if my function to be a surjective function, I should get an output 0 for some input value, right? For what value of x I will get f of x as 0? Is there any x such that my f of x takes value 0?
No.
Or just plot it in the Desmos. Just plot it in the Desmos. I just plotted it in the Desmos. I will show you. Wait. Okay. Is it visible?
Yes.
You see, I'll just zoom out a little bit. You see, this particular function x plus 1 by x will come to -2, and again it will take values from 2. From -2 to 2, my function will not take values between -2 to 2. You can see clearly. So it will not be a surjective. From this graph itself, I can conclude every statement. Okay. The first statement is f is an injective function if the domain of f is R. So is it an injective function? So you draw a horizontal line test. So if I draw a horizontal line y is equals to 15, it will intersect at two different values.
Right.
Right? So it will not be a injective. And next is if f is an injective function, if the domain of f is natural numbers. Is it? Natural numbers minus 0, right? No.
So it's not an injective function, right? Because
Yes, hold on, this is 0.5. Yeah. See, it starts
Sir,
from 1, right?
they told 0 is not there in the natural number, natural
so
number in the beginning of the questions.
in the beginning of the question.
Yeah, they mentioned like that.
Okay,
Natural number
Yeah,
other
yeah.
than 0.
See, from this week, we don't consider natural numbers too. Yeah. There is a note you can see on the right, you can see on the top of the.
yeah, okay.
So don't include 0. So we start from 1. So you start from 1. So now my 1, f of 1 is 2, f of 2 is some other value, f of 3 is some other value. So you see this is an increasing function in the domain 1 to infinite. Okay.
What about less
Once
than
you
1
have the
value?
graph with you, you
we
can
are-
conclude by looking at the graph itself. Okay.
Okay.
From there you can identify. What is the question number? See, activity 3 question number. Is she still there or she left?
So question 8.
Let A be the set of points where the curve C has no tangents.
Yes, sir.
Oh, answer question number. Okay. Let's see, represent the curve in.
This AQ questions also difficult. We are unable to solve few questions from week 6 onwards.
AQ are difficult.
AQ,
Or
some
maybe,
questions.
Some
maybe
questions
I
are.
think, yeah. See, as you progress, difficulty level will definitely increase.
Is there
We
any
need some solutions.
yeah, we need solutions even for
Yeah,
practice
activity
assignments.
questions.
See, when you are asking for solution, try to understand the key idea behind giving you the naming the questions as activity questions. See, when we say activity questions, we expect you to try and attempt that as an activity, not like solving questions. It's an activity to you. You should solve by your own.
But we are getting depressed, sir.
No.
We are not
Once we
getting the
do the
answer.
solutions, see the idea, the fun behind that activity questions will go off. You just
You know,
simply try
Srikanth,
for.
while solving week 6, I had a thought to quit from this
Yeah,
term.
even I felt like that.
No.
No, we should not quit. We should not quit.
It's really huge syllabus. It's really hectic.
I became very
You
low
should
and
try,
I was
but it's
stop
hard, very hard.
asking questions also.
Okay. Don't worry. See, that is why we are here conducting sessions to discuss. See, we will give you an insights of that ideas, or if I take the session, I almost solve the question, activity questions, and
I
we are
think
not
for
supposed.
week 6, there were less sessions. We took
Yeah,
only
Yeah,
one
because only
session, I
one
think, for
session
week
we got
6.
for the solve
It
with
was
us.
really quick. There was
Okay,
no
we
gap
will
between
do one thing then. We will try to arrange one more session for week 6.
Yeah, better.
Yes, please, sir. Please.
Where we will try to.
Dedicatedly for week
Yes,
6,
very
please,
late
for the
for week
graphic.
6.
Right.
For the graphic part, A power X, E power X, log X, for these stuffs, logarithms.
Definitely.
Please try to.
No,
Yeah,
not even
sir.
for graphs. Even for solving, even for log functions also.
Yeah,
it's
even
difficult.
solving also we are getting very confused.
Because in later on, I saw in the syllabus we have limit logarithm functions again coming.
Yeah, it's a mix of
Log will
everything.
haunt
No?
you.
So
Log will
if that
haunt you.
concept is not clear, then we cannot go further.
Yeah. Log functions will haunt you till machine learning and last semester of.
Calculus also, no, sir?
Yeah, even calculus.
Yeah, so it's very important, logs.
Yeah,
So please try to keep a session dedicatedly for the week 6.
Only for week
Definitely.
6.
Definitely.
Yes, sir.
Anytime. No problem.
Anytime, sir. Before the graded assignment 7, we have to finish week 6.
Sure.
Sir, can you do this graded assignment?
Yeah, I will.
question?
Just give me this thing. Give me a minute. I will just explain her. Let A be the set of points where the curve C has no tangents. Okay. Find a lower
Yes.
bound for the cardinality of the set. So you see, for okay, this is an out of box question where we wanted to exclude this, but anyway, see for straight lines, if the straight line is changing suddenly to another straight line, see the points P, Q, R, S. Just look at the points P, Q, R, S. Okay.
Yes.
Are you on the screen?
Yes,
I'm
sir.
just showing you that, right?
Yes, sir.
In my screen, yeah.
Yes, yes, it's visible. Yes.
Yeah. Okay. So this P, Q, R, S. Don't debate with me that straight lines will not have tangent. As of now, just agree that if
Yes,
there is
sir.
a straight line, every point on the straight line has a tangent, and that tangent is the same straight line. If I
Yes.
take a point, some point here, if I wanted to talk about the tangent of that point, the tangent of that point will be the same straight line.
Yes, sir.
Okay.
Yes, sir.
So when it comes to the point P, if I look at the left hand side, I will have a tangent which is of this line. And if
Yeah.
I look right side at P, I will have a tangent which is PQ line.
Yes, sir.
Okay.
Yes,
So
sir.
if you are having two different tangents at one point, I say tangent does not exist at that point.
Yes, sir.
Okay.
Yes, sir.
Now you see at point P, at point Q, at point R, and at point S, the tangent will not exist.
Will not exist. Yes, sir.
Right. So
Yes,
there
sir.
are 4 points where my tangent will not exist.
Yes, sir. So what do you mean of lower bound here?
Lower bound is the lowest value.
Okay.
So we know at least four points tangent will not exist. At least
Will not
4
exist.
points. There can
Yes,
be
sir.
more than 4 also, but we want the lower bound of it.
Okay.
Okay, least
Yes. Yeah.
minimum value.
Okay, sir. Thank you.
Okay. So what is the graded one?
Graded first question, sir. Solve the log.
Sir, also graded assignment solution not released.
It is released, right?
It's there. It's there.
It's there.
Released.
Just yesterday we have released it, I guess.
Yes.
Able to find it.
Can you try to solve this question by taking logarithm or ln?
Ln. Which question?
Ln or log.
This particular question number 1, is it?
Yes, yes, yes. GA1. Yeah, I tried, but I think somewhere I missed it. I couldn't approach the answer. Here, they solve like quadratic equation. They took it as a quadratic equation and they solved the solution.
This one.
But if we solve, if we are able to solve with log or ln, it will be easier.
This particular question itself. 18 power.
Yes, yes. Yes, yes. Can we try?
Yeah, definitely. I will
Yeah,
just
please.
take that journal.
Actually, I tried this question many times, around 10 times, but answer was not correct. Though I was able to do reverse engineering and find the answer, but something is wrong somewhere.
I too tried.
So this is what we have given and we have wanted the value of x. Okay. So in order to take the log, so we know formula for log AB, which is log A plus log B.
Yes.
Right.
Yes.
But we don't know the formula for log A plus B or log A minus B kind of things. So we don't know how to express.
Right.
If I take directly log, I don't know how to split this. Right? Even log 0 is also not defined, so I cannot take directly log.
Now log A by B will be log A minus log B, na?
That is also we know. Log A by B is log A minus log B.
So this 18 by 12, can we do? Can we approach like that? 18x by
Right.
12x?
We will try to modify.
No, we
products
can.
Products or like this divisions. So what I wanted to do is there is 18 power x. I will just I wanted to simply write 3 to the power 2x times
Yes,
2
yes,
to the
that's
power
what.
x. Can I write it like this? So I'm just bringing bases to one, bases to prime numbers.
Now here what my doubt is, if I take log 18 power x minus 12 power x, can I write it as log 18 power x by 12 power x?
No,
Sorry.
that is what I said, right? Log of a minus b, you cannot expand. There is no expansion for this. So log a minus b means log 18 power x minus 12 power x. There is no expansion for these kind of things. So we have
A by
only,
b we can do.
yeah, so for log of a by b, we can split it into log a minus log b. Okay.
Okay.
So that is why
So can't we write log a plus log b as log ab? That we can write.
Log
No,
a
we cannot write
plus
like that.
log b.
Yeah, we can write log A
log
plus
A
log B is equal to
log
log
a
AB.
plus log b can be written as log ab.
Yeah,
But
that we
log
can.
a plus b in the bracket we cannot.
No.
No, we
Even
cannot.
log
That
a plus b, there is no closed expression.
Okay.
Cannot explicitly write. Okay. I am just writing this 12 power x as 2 power 2x times 3 power x. Just see, if you multiply it, you will get the same thing. And this will be equal to 2 times 2 power 3x. Okay. So this is 3 power 2x times 2 power x. I just simply divide. If you can see here, there is 2 power x and 3 power x. There are two things. If you take 3 power x is equals to p, I just wanted to remove those things, power things. You can write 2 power x as some q. Okay, consider just I am taking it as p and q. Now this will be p square times q minus q square times p is equals to 2 times qq. Can I write it like this?
Yes,
Yeah,
sir.
this is what
Yeah.
the approach in the solution.
This is the approach. Okay, I will try it differently
Yes.
then. Don't take it this. I don't want to take this. Just directly divide it by. So as I can see, 3 power x and 2 power x, I just wanted to divide it by 3 power x and 2 power x. Both sides. Okay, once I divide it, I will get, the left hand side will be, I can split it as 3 power 2x times 2 power x divided by 3 power x into 2 power x minus 2 power 2x into 3 power x divided by 3 power x into 2 power x is equals to this side also 2 times 2 power 2x by 3 power x. So just 2 power x and it will be 2 power 2x. So now this and this will get cancelled, this and this will get cancelled. This will be 3 power x minus 2 power x is equals to 2 times 2 to the power x by 3 power x. So what are we getting here?
Same. We'll get the same p square what we did earlier.
Okay. Again, I will divide. I will just take this as 2 power x into 2 power x. I will just bring 1 2 power x. Again divided by 2 power x and 2 power x. And I will get 3 power x by 2 power x minus 1 is equals to 2 times 2 power x by 3 power x. Okay. Now you can see I have this. I can write it as 3 by 2 whole power x minus 1 by 2 times of 2 by 3 whole power x. I'm just doing the manipulations and I just wanted to simplify the given expression.
Yes.
I'm just trying to simplify it, how simple I can do. Okay, now I got 3 by 2 power x minus 1 and 2 times 2 by 3 power x. and this is 3 by 2. I will keep it as it is. This I will write it as 1 by 3 by 2 power x. Now treat it like p now, just to simplify it, that's it. If you don't want to treat it, just bring 3 by 2 to the power x on one side. So cross multiply, you will get 3 by 2 whole power 2x minus 3 by 2 whole power x is equals to 2. Now this became a quadratic 3 to the power x whole square minus
This is simple. This
3
is
by
simple,
2,
but
yeah,
yeah.
3 minus 2 is equals to 0. Now this becomes a quadratic, and here our variable is 3 by 2 to the power x. So I can write it as 3 by 2 whole power x whole square. This I will split minus 2 3 by 2 whole power x plus 3 by 2. I just factorize. So 3 by 2 to the power x. If I take common out, 3 by 2 to the power x minus 2 plus 1 of 3 by 2 to the power x minus 2. So it's just manipulations. All these are just manipulating the same equation. I am just manipulating here. I am just shuffling here, there, trying to get some closed form. So 3 by 2 power x plus 1 times 3 by 2 whole power x minus 2 is equals to 0. Now I have two different values. 3 by 2 to the power x is equals to minus 1, or 3 by 2 to the power x is equals to 2. For what value of x will this 3 by 2 to the power x takes negative value?
X odd power. No, sorry.
Root value.
It will never take. It will never.
Yeah, it will never take.
Yeah.
Because you see 2 power x or 3 by 2 to the power x.
Always
If you draw the
yeah.
graph of 3 by 2 to the power x, it will be something like this.
Yeah, sir.
Right? It will never take negative values.
Negative values.
So there will not exist any x such that 3 by 2 to the power x will be equal to minus 1. So we are left with only one case. 3 by 2 to the power x takes 2, value 2. So 3 by 2 taking x to the power x is equals to 2. What I will do is I will take log on both sides or ln on both sides. When I take ln 3 by 2 to the power x is equals to ln 2. Now you see x times ln 3 by 2 is equals to ln 2. Now we have this, we know this formula. Ln a by b can be written as ln a minus ln b. Right? Once if you write that, x will be equal to ln 2 by this particular ln 3 by 2 can be written as 3 minus ln 2. Is this the answer?
Yes.
Yeah,
Correct.
this is it.
But
So
these
this is
type of problems, it will take some time.
Yeah, it will take some time, but it's just the manipulations. You just have to
Yeah.
turn around the equation and look
Yeah.
at how easily you can write the equation.
But if it comes in the exam,
Yeah, manipulation is very difficult.
Definitely it will kill your time. If we want to be more sadistic, we will
Yes.
definitely give this type of questions.
It
You
will
want
take
to-
at
one more
least
thing,
10
sir.
minutes.
Excuse
Yeah.
me.
Yeah.
Can you go up, because I was lost in between. Yeah, in between here. Bill East, can you stop here? 3 by 2 power x minus 1. How did we get this step? After
Yeah,
that,
I just divided it. See, what I did is simply I just simplified this 18 power x, 12 power x, and 8 power x into
yes,
the
I got
bases.
all these things.
Yeah, you
Only
got
at
these
that
things.
step. At that step, I was lost.
Okay, I just again I just divided it by 2 power x.
Yes.
Okay, if I
Yes.
divide it by 2 power x, 3 power x minus 2 power x by 2 power x can be
Yes.
written. So
Yeah,
this
yeah.
thing can be written as 3 power x by 2 power x minus 2 power x by 2 power x. Right?
Yes,
This
I
will
got
be this.
it. Yeah.
And this is 1. So
And
from
after
here,
that?
this will be this. And even the right hand side also, this 2 power x will get cancelled with this 2 power x. And we will be left with 2 times of 2 power x by 3 power x.
Yes.
Right? Now this 3 power x by 2 power x, I can write it as, you know this, right? A power p by b power p, I can write it as a by b whole power p.
Yes, yes.
Right? The same
Yeah.
thing. 3 power x by 2 power x, I can write it as 3 by 2 whole power x.
Yes.
Here also 2 power x by 3 power x, I can write it as 2 by 3 whole power x.
Yes.
Now this 2 by 3 whole power x, I can write it as 1 by 3 by 2 whole power x.
Yes.
Okay.
Yes. Okay. Okay.
Okay. Once I write it, I just multiply this 3 by 2 whole
Yeah,
power
yeah.
x to the left hand side. I'll get this.
No, I have seen a line between that, so I thought I got confused.
Okay. Okay. Now this will convert into a
Yeah,
quadratic
yeah.
equation.
From here,
where,
it's fine. Yeah.
My variable is 3 by 2. Okay. Okay. Fine. Okay. Shall we
Sir,
end the
one
session
doubt,
then?
sir.
Yes. Yeah.
Sir,
Yeah.
excuse me, sir.
Yeah. Arnab, I can
One
hear
doubt,
you.
last.
Yeah.
Question number 5, week 6.
Question number 5, week 6, graded.
Yes, yes.
Okay. Is it like 2 times e power x by 3 times e power x plus 1?
Yeah.
Okay.
Sir, how that graph is a one-to-one function? I didn't got. In Desmos, it is showing that it is a sigmoidal graph, right?
What is
So in Desmos, I plotted. So there it showed that it is a, from that I concluded it is a sigmoidal graph. But how it is a one-to-one function if it is a sigmoidal graph?
Okay. Is it not 1-to-1? Let me just check.
I'm not getting, the answer is given is 1-to-1. So I am not understanding how it is 1-to-1. I'm not able to.
I will just give you one. So let me just take a look whether we are correct or not. Then I can argue.
Okay.
Okay. Okay. So okay, you are treating that it will be a flat line after some time.
Yeah.
No, that will not be a flat line. Some value will change. How you prove is, as we have gone past 1-to-1 functions, we have f of x given to you as 2 times
2 power x
3 times e power x plus 1.
plus 1.
Right?
Yes.
Now, how we prove 1-to-1 is, I take x1 not equal to x2. I should get f of x1
Not equal to x.
f of x2. So if my inputs are different, I should get my outputs are different. The
Yes.
same thing I can also prove like this. If my f of x1 is equal to f of x2, if my outputs are same, that means my inputs are same.
Okay.
Okay.
Yeah.
So for 1-to-1, both the statements are correct. If you know logic, this is just the contrapositive of this. Okay, statements. These are contrapositive statements. Now, people who don't know how many are there. People who don't know what contrapositive is, just forget about it. So both the statements are same.
I don't know.
Okay, forget. I just used. Okay, take this, you get this, or take this, you get this. If you get this, then we conclude that that is 1-to-1 function.
Yes.
So which one you want to take?
Sir, first one.
First one. Okay. So when I take x1 not equal to x2, my e to the power x1 will not be equal to e to the power x2.
Yes.
Sure. 2 times e to the power x1 will not be equal to 2 times e to the power x2.
Yes.
Okay. Now see, e power x2. Same thing. 3 times e to the power x1 will not be equal to 3 times e to the power x2.
Okay.
And
plus 1 will also be not equal to.
Okay, I will write it. I will write this function as 2 by 3 plus 1 by e power x. Okay. We will take only one, just divided by e power x. Okay. Now it will be easier for us. So x1 not equal to x2. E to the power x1 is not equal to e to the power x2. Similarly, which implies me that 1 by e to the power x1 will not be equal to 1 by e to the power x2, right?
Yeah.
So 3, which will imply me 3 plus 1 by e to the power x1 will not be equal to 3 plus 1 by e to the power x2, right? I just added 3. Now, which implies me 3 plus 1 by e to the power x1 by 2 will not be equal to 3 plus 1 by e to the power x2 will not be divided by 2 will not be equal to this. I'm just dividing it by 2.
Okay. Yes.
See, these all will imply if x1 is not equal to x2, then e to the power x1 will not be equal to e to the power x2 because exponential function is a strictly increasing function.
Yeah.
Okay.
Yes.
So it is an one-to-one function. So as it satisfies, it should satisfy the property, this property. So e to the power, once this is not equal, reciprocals will also be not equal. Even if I add 3 to that, it will not be equal. It will not change much, right? 3 plus 1 by e to the power x1 will definitely be different from 3 plus 1 by e to the power x2. So even if I divide it by 2, it will not be equal. Again, if I reciprocal, it will not be equal.
Okay.
So this 2 by 3 plus 1 by e power x is nothing but f of x1 is not equal to f of x2. Okay.
Okay.
So I have taken x1 not equal to x2 and I have got f of x1 not equal to f of x2. Same thing you can prove it by taking, if f of x1 is equal to f of x2, you will end up getting x1 is equal to x2. Okay.
Yes, sir.
So from this,
Thank
I
you,
can
sir.
conclude that this function is a one-to-one function. So if you have access to graphs, just look at the graph also for better confirmation.
If you're taking the first definition, then we can conclude that f of x equal to x squared equal to 1-to-1, right? Because I can give you the x1 and the x2 which is not equal to, and then which gives me f of x1 which is not equal to f of x2. So in that case, doesn't mean that it is 1-to-1 function f of x equal to x squared.
F of x is equals to x squared. See this x1 and x2. Okay.
Yeah, I
If
can
I
give you
wanted, okay, I will try to prove it. See,
the first one. Yeah.
if x1 is not equal to x2, can I conclude that x1 square will not be equal to x2 square? Is this conclusion valid conclusion?
No. No, sir. No. No, sir.
See, minus 2 is not equal to 2.
Yeah,
But
but
if I
they
square
both
it,
give the same answer.
4 and 4.
Okay. But we can take x1 and x2 equal to x1 equal to -2 and then x2 equal to -1. We can take it, right? In that case, f1 of x1 is not equal to f1 of x.
You are taking one particular thing, but here x1 and x2 can be any real number in the domain.
Okay,
Sorry,
you mean
any value in the domain.
all number it has to satisfy.
It has to satisfy. See, this thing satisfies for every. So
okay.
This will be valid for every x1 and x2 in the domain.
Then it is fine. Yeah.
Shrikant, can you plot graph for me for this function graph?
Graph of this thing. Huh?
Yeah.
This
if
is
you
this.
have time.
So this will be like this. It will start from here. It comes like this.
Now, can you teach me how to draw?
Oh, okay.
Yeah, how we can draw.
See, just identify some 3 points and just understand the end behaviors. So once you got this, just look at when x tends to plus infinite, where will my f of x tend to? So if it is going to plus infinite, 1 by e power infinite is infinite. So 1 by infinite is 0. So this will go to 2 by 3. Right?
Okay.
So from there, I will start plotting.
Now, before dividing itself, if we take the standard function 3 into e power x, from where you show, please? The direct yes.
See, now if x tends to infinite, numerator and denominator will go to infinite and infinite.
Yes.
Right? We will talk about L'Hopital rule in the next week, I guess. So there you will find the limit value when when there is infinite by infinite forms. These are called indeterminate forms. Okay. We'll deeply look into it. Even this has a limit value when
because
the
I tried to plot directly from this f of x, so I couldn't get.
No. See, why you are unable to plot is because of this indeterminate forms. It will go to infinity by infinite, and you know what you don't know what happens to the value when it is infinite by infinite, or 0 by 0, or minus infinity by minus infinite. So these all are called indeterminate forms, and we will compute the limits of this limits of these type of functions where the indeterminate form comes. Okay.
Okay.
So once you know that, then it will be easier to plot for you.
Okay.
Now just simplify this, and after simplifying, I guess you can plot it. Just look at the end behavior. Even if it goes
Sir,
to minus infinite.
is it a sigmoidal graph?
Yeah, sigmoidal graph. Someone said no sigmoidal.
Okay,
I
sir.
forgot what is sigmoidal. What is sigmoidal graph?
Sir, it has a range from -1 to
Minus
1.
1. Okay. Here the range is from 0 to 1. For this function, not even 0 to 1, it will go to 2 by 3. So when x is tending to infinite, it goes to 2 by 3. So I just substitute x is equals to 0, then it will be 2 by 3 plus 1. That will be 1 by 4, 1 by 2. So that means when x is 0, my y takes half value. So I know that this point is on the graph. And when x tends to minus infinite, this will go to, so this will minus infinite, and this is infinite, and this will go to 0. So you see, when x is tending to minus infinite, it goes to 0. When x is tending to plus infinite, it should be 2 by 3. And when x is 0, it is half. So I got this thing. Somewhere you see, you take some two more values here and 2 more values here. Just it will be roughly like this. For our course, it is enough to get the rough values. Most important thing is get the turning points and get the roots and get the end behaviors. No need to be so accurate in the graphics. So get these 3 points, and that is enough for us. Okay.
Sir, can you explain it one more time?
This graphing, no?
Yeah.
Okay. So for graphing, what I suggest is, if you wanted to graph any given function, just check, first and foremost thing is, just check whether there are roots of the function. And just take two values when x is equals to 0, when y is equals to 0. Y is equals to 0 means when f of x is 0. If f of x becomes 0. These all are if becomes 0, that's it. You will get a point from here, you will get another point from here. If there are roots, you will get some more points from here. And if you are not getting these things, just look at the end behavior. And even if you can't conclude, then take random points. Random points, just substitute x is equals to 1, x is equals to 2, x is equals to -1. So in the domain, x is equals to -2. Compute f of x values, random some 3-4 points. So these are, if you got this, and this, that is enough. If you have these three, no need to worry about this.
How
If
to
you
know
don't
the
have any one of
behavior
these,
for exponential functions and the logarithms in end behavior?
and we have basically just identify.
As of now, we know only odd functions, even functions, and behaviors. But
Yeah,
this
and the
log,
behavior.
exponents, logarithms, how to judge the end behavior?
Okay.
Especially when you have e power x divided by something log x and all, you cannot predict it, right?
See, idea to find end behavior is, whatever maybe the function is, just check where the function goes when x is going to infinite, and where the function goes when x is going to -infinite. These are the end behaviors. It is just the checking, whatever may be the function. If my x is tending to infinite, where my f of x is tending, whether it is tending to plus infinite or minus infinite or some particular value.
I used to give 0 and 1 and -1 and then some large positive and negative number. Mostly that will
Yeah,
give you the graph. Yeah.
that will give us the graph. That is what I said.
Okay.
There are two
Randomly take
different
some
values.
points. If you are unable to get the end behavior, or if you are unable to get these roots of function, then
Maybe we can do.
randomly take some values, some positive values, some negative
And
values,
some like, okay.
some larger values, not only -1, -2, also some larger values when x is equals to 100, when x is equals to -100, kind of thing.
Okay.
You no need to find the accurate value also, just get the nearest value.
Okay.
No need to find exact value of f of 100. It's very
Can you
difficult
take
to
any one example with log or e and show once,
okay.
please?
See, let's take this example itself. So f of x, I have 2 times of e power x by 3 times of e power x plus 1. So till now we haven't studied what is infinity by infinite. So we are unable to find the end behaviors of this if the function is like this itself.
If it's easy, teachers no issue.
Yeah. So just I will substitute x is equals to 0, which gives me the y-intercept. So why I said x is equals to 0 and f of x is equals to 0 is,
These are easy.
for this, this gives me the y-intercept, and this gives me the roots
Roots, yeah.
or the x-intercepts.
Yeah.
Yes.
Right. So just substitute x is equals to 0. When I substitute x is equals to 0, I get 2 times e
2
to the power
times
0
e
is
power
1.
of 0 is 1.
So 2 by 3 plus 1.
3 plus 1 is equal to 2.
So 2 by 4, it will be half.
1 by 2.
1 by 2.
So take the xy plane. Just plot this point. When x is 0, my y value is half. So I will plot 0 comma half.
Okay.
So definitely my graph should pass through this point.
Yes.
So however the graph is, the graph should come to this point and cross
Cross the y-axis.
Yeah. If you are not able to get, see, if you want to get the roots, now if I equate it to 0, it will be 2 times e power x will be 0. E power x is 0. So this is no value of x for which e to the power x will be 0.
So no roots.
So that means there will be no roots.
No roots, yeah.
Okay.
No roots. That means the graph will never intersect this line.
X-axis.
So the graph should be above only. Because we know one point on the graph, which is above. And we know that it will never intersect this. So that means the graph will die inside this thing. Either it should be like this or like this. However it is, it should not go below. And also it should cross this point.
What about asymptotes?
Y equal to 0.
No. Asymptotes are not there. Okay. Now, until now, you know these things. Further, if I substitute e to the power minus infinite.
But when it comes to the turning point, how can we judge with this plot?
When it comes to turning points.
Yeah.
Once you plot it, then only you will get the turning point.
Yeah. Okay. Now we judge that it may turn anywhere.
It may turn. As of now, we don't know. We know only 2 things. We know only 2 things, which is graph should intersect or pass through this point 0 comma half, and graph shouldn't touch x.
It will not touch x-axis.
Right.
So to know the turning point, what else we should do?
To know the turning points.
For this function. Am I troubling you?
No, nothing.
Okay.
That thing is when I derivate it, it will, you can directly find the turning points when you know the derivatives. This thing. See, those things we will learn in week 8. Okay, how to derive.
Then no problem, sir. Leave it.
Yeah.
Sir, actually, you have taken only 2 into e power x.
Yeah.
Shouldn't we take 3 e power x plus 1 and equate it to 0 and find the roots for that also?
Yeah, if I equate it to 0, the denominator will, numerator by denominator becoming 0 means numerator becomes 0. Right? I can cross multiply this 3 to the power x.
Yeah, so 3.
That will go off.
Shouldn't we take only denominator?
No, denominator shouldn't be equal to 0.
Oh yeah, f of x is equal to 0 then only.
Just equate it to 0. Just multiply it on both sides. 3 to the power x plus 1, multiply both sides. You will get 2 times e power x is equals to 0. and e power x is equals to 0. E power x will never be equal to 0. That means there will not be any roots.
Actually, these graphs, if we substitute the values directly and find out the f of x for at least like -2 to -2 minus to the values of x.
This will take some time. That's it. But it will
lead to the correct solution.
Correct solution. Yeah. See, now we will try to find the end behaviors. We will just try to look at when x tends to infinite, where my f of x is going.
But e power 2 value, how will we get e power 2?
E power? E power 2 value is, if you know the e value as 2.714. You just calculate using calculator.
I should use the calculator.
Calculator will give the answer. Sir.
Yeah. See, that is what I said. This will take time, but you will get the graph, clear graph. So when x tends to infinite, we are getting f of x is tending to something by infinite. So we are not getting anything from this. Let us look at when x tends to minus infinite. So when x is tending to minus infinite, this is e power minus infinite by 3 times e power minus infinite plus 1. So this is 0. This will be 0. So we will get 0 by 0 plus 1. 0 by 1 is 0. So now I can say when x is tending to minus infinite, my f of x will tend to 0. Tend to 0, not equal to 0. It will tend to 0. Right?
Yes.
Yes, sir. But we will take it to 0.
We will take it to 0. That's it. It will eventually go to 0. Because x cannot take minus infinite. If x takes minus infinite, my f of x is 0.
Yeah.
X will not take minus infinite. X will tend to minus infinite. Okay. So that means when x is tending to minus infinite, my f of x will go to 0. So that means it should be like this. It will not go below x-axis because there are no roots. So it will start from here. So it should meet here. So something should happen here. If you know the properties of exponential functions, we know that this function is a one-to-one function. From above we proved that this is a one-to-one function. So there will not be any curves, ups and downs. So it will be like this, something like this till here. So what will happen after x is equals to 0? Just take some random points, x is equals to 1. You will get 2e by 3e plus 1, which is greater than half. You will get this is greater than half. So something here. When x is 1, something here. So something here. Something here. So you will get like this. So how do we get this? Whether it will go like this or it will go to infinite.
That's what I'm saying, sir. If we only substitute the values only, we will know the turning point. It will take a long time. In the exams, what we do here, we do with Desmos.
You don't have Desmos. See, that is why I'm just giving you the basic and base idea behind how the graphs looks like.
It's good not to use Desmos to solve the problems. I never use just to for the knowledge I'm checking, but for solving, no, I'll never use Desmos.
Even I never use.
So see, use Desmos for understanding.
Yes.
After that, after some when you start understanding the functions and once a function is given to you, this will increase in this region and it will again decrease in this region. Once you are able to get that intuition, then stop going to Desmos. Then start taking the random functions by yourself and try to plot the graphs like this. You first start by plotting, taking some values. Later on, you will eventually, what happens is when you solve more and more problems, when you see some other problem, that will be some sort of replica of problem which you have solved earlier.
So in case of logs also, it's the same?
Yeah, it's the same thing. Work it out from the base. If you don't know anything about
apply the values.
Apply
the logs.
Values. Look at the y-intercepts. So these are very easy ones. Just substitute x is equals to 0. Just look at
these are easy.
Can you get y-intercept?
Yeah.
Just plot that point.
But
Plot some 4-5 points. Look at the end behaviors. As I said, when x tends to infinite or minus infinite, where my function is going actually. Whether it is going to some particular value or whether it is going to infinite.
But in case of logs, it's a little difficult.
Okay, so you try more examples, or see, that is why I said just open Desmos first. Just put whatever the function comes in your mind, put it there, log x square or log x minus 2 or log something, whatever comes in your mind, just put it. Just look at the graph, look at the function, and try to get the end behavior, try to get all these values, what we have seen, y-intercepts, try to get the roots, try to see the end behavior, how the end behavior, if my function is like this, my end behavior is like this. So if I change my function, how will my end behavior, how will my roots change? So it's just like you just play with the Desmos. That is what I say. So start by taking one function, randomly just change the values or change the function. Suddenly you change the function and look at the graph how it changes.
Okay.
And you will eventually get some pattern, some kind of pattern by yourself itself. If my coefficient of x is negative, I'm going to get like this. If my coefficient of x is positive, I'm going to get like this. If my log inside part is never greater than 0, I won't get a graph at all. If my log inside part satisfies for all real values, then I will get my graph on whole R. Like this kind of things. This is what you should try and you should understand. So just try it out, everything. Once, sit for 1 hour, open Desmos. If you don't want to study anything, just open Desmos, play, just look at the graph.
Yeah. It's a good idea.
Yeah.
And there is a question in graded assignment number 4 also. In that, it is a quadratic equation. For that, they have done a log, and they were asking about whether the function is decreasing, increasing, whether it is involved.
Yeah, that question is excluded. Just I discussed it earlier.
Okay, I was not present. This first 15 minutes, I was not there.
Yeah. Maybe at that time I just discussed. We will try to.
What happened to that one, sir?
See that domain is restricted in between -2 to 6, and we are asking you that.
Yeah. That's what even I was wondering.
Yeah. So yeah, that will be an add score.
Okay, sir.
Okay then.
Yeah. Thank you, sir.
Yeah, thanks.
Please try to arrange for week 6 session.
Sure. That's in our
But
bucket
before
list.
this week, because again week 8 will release and we will be in trouble to learn.
Right. We will try to arrange within a couple of days.
At least one session as of now for week 6. Then you can decide for later.
Sure.
Okay.
Sure.
Okay, sir.
Yeah,
Okay, sir. Thank you so much.
Thank you.
Thank you
a lot.
so much.
Yeah.
So for stats, you are only coming today?
No, I was working in stats 2 in the next term.
Oh,
Okay.
Thank you.
If you guys pass, I will meet you there also.
Okay, sir. Stats are
After
so.
going through this week 6 maths, really the doubt is there for me.
Okay.
Will I pass or not in the exam?
No. Don't. If you get doubt on yourself itself, you can't move forward.
This week 6 really troubled. Time is less and there were no session
Yeah,
also.
no session also. We couldn't clear our doubts.
Yeah.
Even for activity question, we
A
struggled.
lot of activity questions are
logarithmic functions.
not able to do. What should we do, sir?
For what?
There are many activity questions I am not able
Unable
to.
to. Yeah, even
what
for
should
me,
we do?
even for me.
Solving logarithms.
I dumped like a pile over there in my book.
Yeah.
Lots
There
of
are many
space
activity
between
questions. In every section, there is a doubt.
There is a doubt. Okay.
Yes.
We will try to keep an organized session then. We will try to keep a session such that we will start taking questions from activity 6.1.
Yes.
Try solving them.
Yes.
6.2, 6.3, 6. The difficult one.
At least 5 or 6 problems. If you clear the doubts and all, then it will be fine.
My suggestion might feel little. Actually, for at least for week 6, for all the activity questions, can you provide us a solution only for week 6?
Yes, sir. That's a request
For all is difficult. See, for difficult question, we can start providing you.
Yeah.
So only for week 6, I'm asking, sir.
Yeah,
not
only
for
for week 6 itself. I am talking about.
Otherwise, keep a session that will be better.
Yeah,
it will enter into
session
your
will be
brain.
better, right?
Session is
Yeah.
better.
We will try to discuss
Session will be okay.
all the questions, all the difficult questions. We will try to cover all the difficult questions. And if you have any doubt further also, you can come back to the session and look at the solution.
Yes, that's much better.
Okay. We will try to arrange. Definitely, we will try to arrange.
Okay, sir. Thank you so much,
Yeah.
sir.
Thank you.
Thank you so much. Thank you.
Thanks a lot. And bye all.
Bye.
Bye.
Bye-bye.
Host, are you there? Host, you can end the session now. I am leaving.